Morning, everybody. Online, can you hear me? Can you see the screen?
Yes, sir.
All right, good. Hold on a second. Online, can you hear me? Can you see the screen? What is this?
Yes, sir.
I don't understand you. So, are you ready to start now? What is it easy? I hear the whole time. Anyway, guys. So this is the first session that we're gonna do. We go through some multiple choice, some preparation work for the multiple choice exam on June 6th. You've been practicing and getting some good grades, but we don't know what's coming in the exam paper. Right? And we can't take it for granted. So now because you're getting good grades in the practice papers, we're gonna relax and not do what we need to do. Today we want to focus on the topic of set. Now, what you see on the screen here is basically the syllabus. All right. So these are the topics for the paper one. It's two sides of it. Well, this is the paper two, the paper two already. So we're focusing now on paper one, right? Paper one, getting ready for the paper one. Paper two gone already. And basically, this is it's an idea of how the paper one is set out. So it's an hour and a half exam. And these are the topics. You have 60 questions, 60 multiple choice questions. These are the topics. So there are 6 topics on number theory. There are about 6 questions on set. 8 questions on consumer arithmetic. 6 algebra questions. 6 statistics questions. 8 measurement questions. There are 8 function relations and graph questions. 8 geometry trick questions. 4 vectors and matrices questions to make up a total of 60 questions. Now, all these topics, except this one, we would have covered in preparation for the paper. All right? We would have covered everything there except sets. Because sets is the only topic that is not on paper 2. And that's why I'm starting this paper one journey, or this paper one prep work with sets. Well, I want to be able to go through all of these topics with you to give you a strategic approach for the questions, how to approach the questions. I know that a lot of people depend on memorizing answers. But I'm going to show you in this exercise, even today, how what you will find is that a lot of the questions sometimes look like the same question, but they're actually asking something different. Sometimes the information on a question is the same, but they are asking something different. Sometimes they make very, very small, almost insignificant changes to question. Well, significant, but so minute are these changes that you don't see it. Right? And so going in an exam room, depending on the memory of questions and the memory of answers, can be very disastrous. You get me? Because they will make changes to the question. And the fact of the matter is that CSEC, they know that all these multiple choice papers are out there available. They know that all these multiple choice papers are out there and people have them. They know some Mr. Shaw have all of them, for example. A lot of teachers have all of them. Because we teachers in the field, we share the papers. We get them, we share them with each other. So they know that we have them, and we expose our students to them. And so the best thing that CSEC can do, because multiple choice questions are difficult to write enough. Multiple choice questions sometimes are more difficult to write than even a paper 2 question. So you find that they keep repeating the same questions. But to make change, because they want to make change, they put at the same question and then they make some minor changes to them. They might have a question where, for example, they have 3/2. Every year they have 3 over 2 on a question. And no one just change it 2 or 3. Simple as that. You might not even notice. You might have a question where every year a value in a question is -2. And then another year comes, they just change it to a +2. I don't even notice. Right? Simple thing like that. Right? I see a year 1 year, they have a question like they would have 2 cubed, like they have 2 cubed minus say 3 squared or 3 cubed. Year in year out they have that, for example. I want you to just make a simple change like 2 cubed, same 2 cubed minus 3. Instead of 3 cubed, let's change it to 3 squared. And people just think it's the same question that they set all the time and give the answer. And oftentimes, the answer for this one is still there. But this one that I said, no, they change it to that. I don't even notice. So you cannot go in the exam depending on the memory of questions. Please, do not go in the exam room depending on memorizing answers. You have to know how the questions are done. You have to know how the questions are done. Right? No, it's almost unavoidable. You're going to go in the exam room and you're going to get caught into this mode of just no the question number, this is the answer, but do not question number, this is the answer. It's almost inevitable. You have to be deliberate about not allowing that to happen to you. They actually work in the question and making sure. You get me? Another thing is that persons go in the exam room and a lot of questions are repeated. And they finish the paper in 15, 20, 30 minutes in an hour and a half exam. And they come out of the exam room rather than stay in the exam room and go back through every single question and just make sure that you really answer the right question. Right? Because they say the question repeat and the shade, and the question repeat and the shade, and the shade, and the shade. Not knowing that I'm good, maybe 10 of them have some of the small differences. I don't pick up. I think it's the same question and something different. I've seen it time and time again. You get me? Now the thing about this multiple choice paper, guys, I know that a lot of you really need, not want, a lot of you need to get 58 out of 60. So you can't go in there giving away answers because you're depending on memory. And see a question and think it's the same question and share the answer that is not right. And next year you come out of the exam room and you only get 50. When you could have gotten 58, I could have gotten even the 60. Something to say time and time again. You cannot have that false sense of security when it comes to the multiple choice paper. You have to be guarded against that. You have to be deliberate about ensuring that we don't fall into that trap. Right? Have to be deliberate about not falling into that trap. And especially because maths is the last exam. And you will find that the majority of the multiple choice papers that you do before, there are a lot of repeat questions. And so you get into this mode of, the question might repeat, the question might repeat. And the maths is the last one you want to get rid of it, and you just want to do the exam and think. Right? And then you just fall into the trap. And we should have get 50 and 59 out of 60, end up get 50 and 49 and 48. It happens all the time. You get me? And when you come out to the exam, you say, easy, easy. Only to when somebody go through it and say, you realize some question where you think you get right, wrong. Because CSEC, you know the mistake that you're going to make with that when doing a question, you know. If I'm writing a multiple choice question, I know the mistake that somebody is going to make, and I put an answer on it that is aligned with the mistake that you're going to make. So when you make the mistake, I see an answer there that is wrong, you're going to shade it, thinking that you do the right thing. Because the people who write the question, they know the mistake that people make, and they put the answer there, right? That will match the mistake that you will make. Right? And so, a lot of the time, because you see an answer there that you get, not realizing that you actually made a mistake. You come out thinking that you're good. So let us not take this multiple choice for granted, please. Right? Let us not take it for granted. All right. So as I said, I basically have work for all these questions, all these topics, but I want to start out with the sets. Because the only topic that would have not done in preparation for the paper 2. All right. So this is actually a question bank of basically all the questions, maybe for about 10 years. And this was up to 2024. I've not updated it to 2025 as yet, but it's up to 2024. If I look and I see any new questions, then I'll expose them to you as we go. But I'm just working from this document today. All right. So if I go down, you see, for example, I have the first topic, and I have a number of questions on the first topic here. But I'm skipping all of this. We'll come back to this at some point. I'm going to go down to sets right here. And I want us to do 2 topics today. If we can do sets and consumer arithmetic today, that will be good. We can do sets and consumer arithmetic today. That will be good. So we can do sets maybe for an hour and a half, and then we take a little short break, and then we'll do consumer arithmetic. Now, the next thing is that I don't want it to be me just going through the questions. So I want it to be that I explain a question, for example, and then I'll give you like a minute or less, 30 seconds to do a question and see what the answer is for yourself. And then I do it. Rather than me just working all the questions like that. All right. All right. But before I get into sets, though, I want us to, just do some little background information. Sets is a topic that a lot of you should know because they teach sets at prep school. What form in high school I got you sets again? Second form, grade 7. So I want us to just do a little quick thing. Just remind us of some of the key things with sets. I'm gonna do it under here. Just coming out the top of my head. Some of the basic things in sets. And then as we do the question, some other stuff might come up, right? Let's talk about some of the basic things in sets. So a set can be represented on a Venn diagram, which is usually a rectangle with circles in it representing subsets of that Venn diagram. You can call this one A or you can call this one B. Now these 2 sets, A and set B, they intersect. The rectangle usually represent what we call the universal set, representing the letter U, for the universal set. I was saying set A and set B. And a set can show number of values in a set, as well as it can show the actual values in a set. So for example, I could populate this set with some letters, with some numbers. No, let me use some letters, like A, B, C, D, E, F, and put G outside this. This would be an example of a set that is showing the actual values. But I also do a set that shows the number of values. So instead of A, B, C here, I could put 3. You see that there are 3 elements in there. Instead of the D right here, I could just put 1. So that there's 1 element there. Instead of the 2 values here, I could just put the number 2. Meaning that there are 2 elements in there, and then I could put another 1 out here to say that there's 1 element out here. So a set can show the actual values or the actual elements or the actual members, as well as it can show the number of values in the set. A set can also be constructed to show percentage. Can also be constructed to show percentage. Now, when it is constructed to show percentage, and you see percentage question sets as well, you have to remember the total percentage has to be 100%. When it is shown, when it is given as percentage, the total must be 100. So basically here, 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 and here must add up to 100. So for example, if I know that this is 20 and this is 10 and this is 40, what that going so far? That's 70, right? Then out here, so half will be 30%. If I'm showing percentage. Good? A set can also show probability. Can also show probability. So if I'm showing probability, what you have to remember about probability, the total probability is 1. Total probability is 1. So here might be 0.2 probability of getting an A only. Here might be 0.3. Here might be say 0.4. The total has to be 1. So these add up to how much so far? That add up to 0.9. So out here has to be 0.1. But the total probability has to be 1. So that, remember, a set can show number of values in the subset. It can show the actual values in the subset and actual numbers. It can show mute the mic, please. It can show percentages, and it can also show probability. All right? You can do all of that. All right, so let's talk about some of the set notation now, the set symbols, right? Let's talk about some of the set symbols. So pay attention now. So two finite sets, A and B. Inside here is A only. Pay attention now. Inside there is A only. Anybody know the set notation for A only if you have just sets A and B? Huh?
A with no. A only. Is it A with a little something up right top, one little one or something like that?
All right. So watch this now. A this is a complement of A. It means not A. That's what that means. Not A. Everything outside of A. So if I'm drawing the Venn diagram for not A, all right, it will be this. Then not A will be everything outside of A. So I'll be shading everywhere out here. Let me see if we can use the highlight. Everything, that too. Everything outside of A. Everywhere outside of A. That is A complement. Everything outside of A. So here I have shaded A complement. So B complement is something similar. See? Only A is left unshaded. That will be A complement, meaning not A. Good?
Okay, sir.
Over here now, I'm talking about in this Venn diagram that has A and B in it. How do we represent inside here alone? Meaning A alone. How do you write it as a set notation? It means it's A and not B. That's what inside here is. A and not B, because you're not including this part. You don't want this part in it if it's A only, because this part includes B. So you want A and not B. So the set notation for that section is A intersect B complement. So you're inside of A and you're not inside of B. But understand that. And the same thing up over the B side over here. So inside here alone is B only. And that now would be B intersect A complement, meaning you're in B, and this inset notation means and. This, the intersection symbol, that symbol, it really means and. That's a word you use for it, and. That's a word for that symbol, and this symbol right here, an intersection symbol. Then what does inside here mean? Let me take out the shade. Let me take this out.
U. A U B. A union B.
No. Inside here I'm talking about. What does inside here mean? What is that section? Inside here. Inside here.
Subset, I think. I'm not sure.
All right. That is A intersect B. That's the region where you have A and B occurring together. That's A intersect B. That's A and B. What about outside here? What about outside here? Anywhere outside here now? What is that section? What is that section? That is a complement of A and B together. So look here, inside here, everything together inside here is a union of A and B. So if we are outside of that region that I've shaded, I'm in the complement of that union. That's what outside here is. This is that is outside of A and B. So that would be A union B complement. Okay, you're outside of the union and A and B. And then A and B together now, if I were to draw A and B together, I must do a Venn diagram for that down here by itself. But put A and B combined. And I shade everything inside A and B right here. Everything inside A and B combined. Then that is the union of A and B. That would be A union B. Now the union, the word for union is really or, believe it or not, it is or. But this or is called the inclusive or. So it means A or B or both. That's what it means. This symbol is the inclusive or. So it means A or B or both. Meaning you can take A, you can take B, or you can take A and B. A or B or both. All right, so that would be the union. And that's why out here now, the complement of that union. All right, so let's start out with those symbols. Let's start out understanding.
Hold on, sir. Hold on. So over this side, over to the left-hand side, AUB, so it's a complement outside of the bracket.
Yes, this
Okay.
one. All right. I mean that you don't want, you're outside of the union. That's what this means. The complement is when you're outside of that region, outside of that set. Get me? And use it in sets with numbers as well, which you're gonna see. All right. All right. So I'm just introducing to those symbols to start. So if I give you this set, which you're gonna see questions with it. And this is A and this is B, and I shade inside here. What's the set notation for that? That I've shaded. What's the set notation for that which I've shaded? It's simply just A. Because I've shaded A. Everything in A. Simple as that. It is just set A that I've shaded. That is it. That is set A that I've shaded. All right? Huh? Huh?
Just A.
Yeah,
And if you
just
in a bracket, in a open and close bracket.
this is just set A. When we like this, I just set A. Sometimes let's put it without the bracket. Just set A. All right? All right. So I want to introduce you now to a set formula that you all must know. A set formula that you all must know for the same two set A and set B. Combining the intersection and the union and stuff. And it's simply this, with respect to the number of elements, right? It is this. The number of values, this n in front, if I write this, NA, this means the number of elements in set A. That's what it means. The number of elements in set A plus the number of elements in set B will always be equal to, for any two finite sets, will always be equal to the number in the intersection plus the number in the union. It's a very important formula to remember.
Go on again, sir, please.
It's as simple as that. The number in A plus the number in B is equal to the number in the intersection plus the number in the union. Simple as that. So whatever them two you add up to, them two you must add up to the same thing. That's simple formula to remember. The number in set A plus the number in set B will equal to the number in the intersection plus the number in the union. Huh?
Sir, draw one something there.
So
Me
this are
not get
three.
it.
This are 3, and this are 5, and this are 3, and this are 5, and this are 6. Then this upper gonna be equal to this upper equal to this upper equal to. Right? Because 3 and 8, 3 and 5 are 8. So if this are 6, this upper equal 2. We're gonna see question. Just remember this formula. I'm not gonna bother get into explaining the formula. I'm going to explain the formula. Let's explain the formula. Can maybe appreciate it better. I'm explain the formula, right? Let me explain the formula. This is A and this is B, right? Let me start with the union as a subject. Yeah, for the explanation. Let me start with the union as a subject for the explanation. So let me copy this down and then let's do it. All right. I'm proving this formula for you. But I'm going to start out with the union. So A union B, the number in A union B is going to be equal to the number in A right here, so don't think. That's all. It's going to be equal to the number in A, which is everything that I've shaded there. Plus the number in B. Pay attention now, so let me use two different colors. Let me use some colors. So this will represent the number in A. If I shade everything here, that's the number in A, right? So write number in A in red. Number in A. Plus the number in B, but let me put the number in B in purple for you. So the number in B here now, this will be the number in B. I'm going to add the number in B. What is the problem that we have right here? Anybody can see a problem right here? The numbers in A is in red. The number in B is in purple. Do you notice a problem in this situation?
They have a union. They have a union.
So this is a union. The union is the number in A plus an A. I'm starting out as the number in A plus the number in B. Do you see what the problem is with this formula? Don't you see that I've shaded the intersection twice? Intersection is shaded with the red and the purple. It means that I'm adding the intersection twice when I do A plus B. See that? So I'm going to subtract it one time then for it to be true. So I'm going to subtract the number in the intersection. A intersect B. One time. I've subtract it one time. Because the number in A includes the intersection. And the number in B also includes the intersection. And so I've added the intersection twice. So for it to remain true, I have to subtract the intersection one time. But understand that? Then if I take this intersection I've subtracted and bring it over this side, that is how you end up with the formula that I just showed you. The number in the union, A union B. When this comes over onto this side of the equation, it becomes plus the number in the intersection, A intersect B. You're going to be left it equal now to those two, plus equals the number in A plus the number in B. But I just wrote the formula with the number in A, this side on the left, and this side on the right. Get me? So that's a nice, easy way to remember it. So the number in A plus the number in B must equal the number in the intersection plus the number in the union. That's very important. You will not do a sex test, a multiple choice paper and not use this formula somewhere. You must get a question or two where you have to use that formula. All right? And then easy. Easy. I'm going to see examples with it. I'm just introducing those things there now. For now. All right. So that's a set formula. Let's talk about another thing now, which is the number of subsets in a set. The number of subsets. Number of subsets. Equals 2 to the power n, where n is the number of values in the set. Let's do a simple example. All right. So let's say we have a set with 3 values. I'm going to put the set like this now. 3 values. Let's use P. Let's use P, Q, and R. And from the set P, Q, and R, we want to write down the subsets. Now, based on that, the n equals 3, don't it? N equals 3, don't it? So I'm saying that this must have 2 cube subsets, don't it? Number of subsets will be equal to 2 raised to the power 3. C is always 2 to the n, where n is the number of values in the set. 2 cube is equal to 8. So I'm saying this set, which has 3 values, must have 8 subsets. But I give it that? 8 subsets. So let me list those subsets now to prove to you that there are actually 8 subsets we're getting from this. Let me list them for you to show that you really get 8 subsets.
PQ.
Formula is true. All right? All right.
PQ.
All right. No, just don't pray. Don't pray. All right. So I'm just list the subset. I'm gonna list the one that is just one value each first, one element each first. So you're gonna have a subset with P, you're gonna have a subset with Q, and you're gonna have a subset with R. But I get that? You're gonna have some subset with 2 values, right? So one, you're gonna have a value, you're gonna have a subset with the P and the Q. You're gonna have a subset with the P and the R. And you're gonna have a subset with the Q and the R. But I can't get that. Those are subsets with 3 values. So we have 6 so far. We need 2 more. What do you think the other 2 are? The other 2 subsets are?
The other one would be PQR.
One would be PQR, yes, good.
And
An empty set is also a subset.
oh,
2 sets
what?
are the empty set and the full set itself, PQR. So we have to remember that the null set is a subset of every set. And the full set also is a subset of every set. The set itself is a subset. All right? So these 2 up here, these 3 up here, are what we call proper subsets. Proper subsets. Just in case you want to ask something. And this down here, these two are called improper subsets. And that's how you get the 8. But this way you have to remember, this way you have to remember, this thing in the box right here. Number of subsets is 2 to the n, where n is the number of elements in the set. Get me? Better go to that. Better go 2 to the n.
Yes,
remember.
sir.
All right.
Yes, sir.
The next thing I want to talk to you about, the CSEC asks sometimes.
Hold on, sir. Take one screenshot away just so. Hold on.
The next thing I want to talk about is something that CSEC said sometimes, which the term equivalent sets. So it's simple. 2 sets are equivalent if they are the same Malik Mills. Pay attention now. Hey. 2 sets are equivalent if they have the same number of elements. As simple as that. So if I write a set A, and set A has the values 3, 4, 5, and I have a set B, and set B has the values P, Q, R, then these 2 sets are equivalent to each other, but have the same number of values. Simple as that. A is equivalent to B. And sometimes write it like this. A is equivalent to B. That's what I write it sometimes, equivalent. Simple because the number of elements in A, the number of elements in A is equal to the number of elements in B. That number is 3. 3 in this and 3 in that. 3 elements in A, 3 elements in B. So the 2 sets are equivalent sets. All right. So I'm giving it that as a start, guys. That just come out of my head. I don't remember anything else to tell you just now. I guess anything else, repeat them up on the questions as we go. So I'm going to do some questions now. So I'm actually going to do the bank of questions for the past 10 years up to 2024. All of the sets questions there for the past 10 years up to 2024, from 10 years before 2024, up to January 2024. So June 2024, not in it, and January 2025, not in it. Just 10 years before June up to January 2024 is in this. All right. So when I look at the June 2024 and the January 2025, I see any other set questions that are different from these, I will cover them for you in a subsequent session. All right. So let's go back up to the sets now. So we're doing questions now. And one of the aims that I have in this session as well is to show you how they set questions and sometimes how they make minor changes to questions. All right. So ready? Let's go.
Yeah.
Hey. First question. This is a sets question. Comes under the category of sets. It says, which of the following describe a set of integers greater than -3 but less than 6? Greater than -3. Hold on, what's happening there? It's gone. Go back up. Greater than -3. Greater than -3 but less than 6. Which one of these? Which one of these? No, remember, guys, something I always tell students, another thing I always tell students. Remember, the correct answer is on the paper, you know. The answer is on the paper. So no make no sense if you pick the wrong one. And the correct answer is there. Yeah, the answers on the paper. So sometimes you use the answers, you use a process of elimination to see what is the correct answer by eliminating the wrong ones. But the correct answer is there. You get me? So sometimes you can't really, sometimes I don't know. This one is okay, but sometimes I don't know how to work with it. I'm not talking about this in particular. Just want to make that know before we start. That the answer is there on the paper. I see sometimes students get a question and they're working out, doing a lot of work. A simple question like, just tell you quick, a simple question like, for example, if you have, say, they give you a question like, say, I see if I can remember one in particular, like, let me give you 450 times, and I give you 0.47. All right? And I give you some answers. Let me see what the actual, let me give you some answers for this. Let me just give you an example. So you don't have to work out everything, right? Let's give you an example. You don't have to work out everything. Let me just give you an example. So 450 times 0.47. All right, so the answer, so some answers I might give you is this. I might give you 0.2115. I might give you 2.115. I might give you 21.15. I might give you 211.
211.5.
All right. This is A, this is B, this is C, and this is D. For example. Now, some people may say they feel like they have to actually calculate this. You don't have to calculate this. Because all these values are the same digits. It's just that it's just the size of the answer you really want now, you know. Is the answer at 10? Is it at ones? Is it at tens? Or is it at hundreds? Now, if you look at this, you know, I don't have to calculate this, you know. I just need to know if it's at tens, at ones, at tenth, at ones, at tens, or a hundred. The answer is in the hundreds. I don't have to actually calculate. Some people say they have to actually calculate that. You don't have to calculate it. This is almost 0.5. This 0.4547 is almost 0.5. So a rough calculation is that you're taking 0.5 of 450. 0.5 of 450 is half of 450. That will be 225. So you know, so the answer is in the hundreds. So without calculating it, this has to be the answer. The one that is in the hundreds. It's the only one that is in the hundreds. Well, that's what I'm saying. So not everything on the paper you have to calculate. The answer is there. You have to be smart. Sometimes we look at the question and don't look at the answer. Sometimes look at the answers before you start working on anything. But sometimes we tend to try to work this out first and then see if the answer is there. No, look at the answer. So when you read a question, you must get into the habit of looking at the answers, and based on these answers, you say, okay, for this question, I really only need to know what the size of the number is. Because all the digits are the same. All the digits are the same. You get me? So we need to practice that way. We need to practice that way. Not everything
Sir, you have to teach the mathematics then, sir. Yeah, you have to teach the mathematics here, because we don't know.
All right, that's right. That's what we're doing. Anyway, so this one now. We want a number that is greater than -3, but less than 5. Less than 6. Sorry, which one of these? Which one of these is the answer? And it's an integer. This Z means integer. It means integer. The Z is a symbol for integer. So this means X is a member of integers. So I think I should talk about it. This symbol means is a member of. And the Z is for the set of integers. What are integers? Integers are positive and negative.
And negative numbers.
What is N? What does N represent?
Natural numbers.
Natural numbers. And natural numbers are your counting numbers starting from 1.
1.
So natural numbers start from 1. 1, 2, 3, 4, 5, 6. Counting numbers. And then what is the what is W? What is W?
Whole numbers, and that starts at 0.
Whole numbers start at 0. Whole numbers start at 0. And then, what is R?
Rational numbers, and those are
No.
right there.
R is for real numbers.
Real numbers. Oh,
Real numbers. I really only deal with the real numbers at this level. Right? We really only deal with the real numbers at this level. Rational numbers is a Q they use for rational numbers. Q.
oh,
What is a rational number? Huh? A rational number is a number that can be expressed as a fraction with an integer on the numerator and an integer on the denominator. So for example, square root of 2 is not a rational number because you cannot express the square root of 2 as a fraction with a whole number on the numerator and on the denominator. You get me? Square root of 2, square root of 3, square root of 5. The irrational number, these are called irrational numbers. What they do, they put a complement on this for the irrational numbers. So like the number 4. 4 is a rational number. Okay, I cannot put it over 1 and form a fraction with it. So it is a rational number. 2/3 is a rational number. Believe it or not, pi. The pi is not a rational number. When we write pi as 22/7, 22/7 is just an estimated value of pi. So pi actually is an irrational number. Another thing about an irrational number is that when written as a decimal, it is non-ending, it never terminates, and the values don't repeat. The values don't repeat. So for example, if it's a number like this, 0.21212121 repeated, that can be expressed as a rational number because the 21 is repeating all the time. So once you see the values repeating like that in the decimal, if it discontinues on forever, it means that that is a rational number. It can be expressed as a fraction with an integer numerator and an integer denominator. You see pi, if you put pi on the calculator, the values don't repeat. And it's a non-ending number. So the 22/7 is just an estimate of what pi is. It's not the true value of pi. It's just the best estimate of the value of pi to a number of decimal places. All right? That's irrational number and rational number. But let us not digress. All right, we spend a lot of time. What's the answer for this one? Yes?
Sir, one at a time, sir. 9 pi can be 3.142, sir.
That's just a few digits of pi. That's just a few digits in pi. Pi is a non-ending, depending on the calculator that you have. Pi, you put pi in the calculator, you get an endless number of decimal places with none of the values repeated. That's what pi is. Where you go? All right. Pi. See it there, sir? Look at it. See the value of pi there? 3.1415926535897. And if you have a calculator that can show pi as an infinite number of decimal places, a non-ending decimal. This calculator does show that number of decimal. What is that? 3, 6, 9, 12, 13, 14. This calculator shows 14 decimal places. That's pi. A non-ending decimal. It's an irrational number, and those decimal values are not repeating. There's no repeat on the decimal values. So pi actually is an irrational number. All right? So whenever give you as 22/7, which is a rational number, 22/7 is just simply an estimate of pi. So if I put 22/7, it's going to come close to this pi value right here. If I put 22/7. 22 over 7. See? And 22 over 7 are repeating. See the values, is that line above it means that those values are repeating. 3.142 is just the best estimate of pi. 22 over 7. But 22 over 7 actually is a rational number. The actual value for pi. Look at the difference, you know. That is what 22 over 7 is in actuality. But pi is this. It's pi, you know. That is pi, not the same. You get me? So 20 over 7 is an estimate, the best estimate of pi. That's all I have to do. Anyway, we keep it, diagnose it. All right, what's the answer for this one? Greater than 7, but less than 6. They want the x to be greater than, not 7, greater than negative 3, but at the same time, x must be less than 6. Which one of them is the answer?
D.
Last one. Because it's just an interval. So the x is between negative 3 and 6, not including the negative 3, not including the 6. But look at this question over here now. This come up on another exam paper. Now, a lot of people see this and think it's the same question, but actually not. Because of the word from. The word from means that you're now including the negative 3 and the 6. The answer is different. This one, you're including the negative 3 and the 6. That says from negative 3, means that you're starting at negative 3 and you're going up to 6. So the answer for this one includes the equal. So it will be this one. So that's why we cannot go in the exam and swap answers, guys. First example, I'm showing you. A lot of people think it's the same question, listen up. It's not. Answers are different by simply this word from on this one. And from means that you're including the negative 3 and including 6. So the equal is on the inequality for this one. See there? The equal is on it. The inequality. Here the equal is not on it. Because it says less than, greater than, and less than. Means that you're not including them. But see that difference? So it's the first example of why you must not go in the exam and swat answers. I might say, answer, no, the question, the answer D. No? Different question, because the word from is here. Different. Next example. Which of the following set is defined by this? Which of these sets represent this? So you see, you're greater than negative 2. Equal means that you're including negative 2. You're less than 4, including the 4. So basically between negative 2 and 4, inclusive of all the values. And you want the whole number, the integers. So the last one. But I can say that last one. All the integer values from negative 2 to 4, inclusive of the negative 2 and the 4. And I could have easily changed this, right? And maybe put just a less than alone here, so. And that would mean that you can't have the 4 in there. You can't have the 4 in there. You get me? So you have to look out for that. So if for example, if the change, they might set this question again, you know, and then put this on this one and put that. And in that case, the answer will be this one. By just simply making that change. If CSEC make this change and change this to a less than and that change that to a less than, then the answer is going to be this one right here. That's why we must not depend on the memory of answers, guys. We run into problems. All right. Look at this one now. This one says, see here, this Venn diagram refers to two intersecting sets P and Q. The number in P is 5. The number in Q is 9. The number in the union is 10. And this question is asking us for the number in the intersection, the shaded region, which is the intersection. The shaded region is P intersect Q. Just asking us for this. What's the answer for this one? This one easy. Remember I told the formula earlier that the sum of these two must equal to the sum of this one and the intersection. number in P intersect Q. Them two here must equal to them two there. So this is 5 and 4, 5 and 9 is 14.
4.
This is 10, the answer down here so must be 4. So this is
4.
4, simple as that. Has to be 4. This has to be 4. This 2 add up to 14. So in order for this 2 to add up to 14, this has to be 4. This must be 14 as well. But go to that, simple as that. This is the exact same question over here. This is the same question over here. We see the same question is on a different exam paper. Same exact question. But this time they ask you, they never say what is shade video. They say, what is this? Answer is still 4. Answer is still 4 right here. All right. So you do this one for me quickly. This one down here. Do this one for me quickly. What's the answer for this one? The number in A, the number in the universal set. This means universal set is 25. But the number in A is 14, the number in B is 15, the number in the union is 23. What's the number in the intersection? What's the answer for that one? What's the answer for that one? We're supposed to blur it out. What's the answer for that one?
2.
What's the answer? Somebody said 2. Nobody else?
6.
Somebody said 6. Nobody else?
The answer is 6, sir.
What you said?
6.
Somebody
6, sir.
2. Who else?
6, sir.
The 2. Come on, no, man. This thing is easy, no, man. Them 2 here and them 2 here must equal. Must add up to the same. Them 2 up here so add up to 29 right now. So them 2 here must add up to 29 as well. So if this is 23, then this have to be 6. So the answer is 6. But that's it. What do we do that? What do we do that? Come on, man. We're gonna get them things right wrong, man. They're too easy. Get me? Number in A plus the number in B must equal to the number in the union of A and B plus the number in the intersection of A and B. Simple as that. So since the A and the B up here so add up to 29, then the intersection and the union must add up to 29 as well. So if the union is 23, the intersection have to be 6. Because 23 plus 6 equal 9, equal 29. So that have to be 6. You understand that? All right. Now do so many things. I'm going to do all of them alone. Come up here, some man. Ready? Let's look at this one. This one over here, so first, that is unshaded. This one. Unshaded. So P is this set, Q is this set, S is this set, and they ask you, what is this? P intersection. What is the answer?
2, sir. A.
The answer is A. It means what is the intersection of the 3 of them? What is common to all 3 of them? That's what intersection is. In and P and Q and S. What is in all 3? The 2. 2 is in this, 2 is in this, 2 is in that. The only one that is in all 3. See that? The answer is this one. All right, do this one for me now. Got this one. Do this one for me now. See it? A different question, you know. You might say this and know the answer here, so. I know say this are 2. They give you about the same 3 set on a different exam paper. And this time I just put a bracket around these 2 and put a union in there. You might think I'm going to shade A to 2. But I remember the answer is 2. I look like the same question. You will depend on memory. Your brain might tell you that this and this is the same. It is not. You might think it's the same question. They give the same 3 sets. And they ask this time in a different exam. What's the answer for this one? I'm going to work out this one.
I think I see.
Sir, C.
How will you work it out? You want the 3 sets. There's 3 sets in there. See 3 sets here. These are the 3 sets. Okay. I'm doing this question now. We're going to work it out. We need to see what the union of Q and S is first, and then do the intersection with the P. We need to write the set for the union. So the union is a combined of the Q and the S, but you don't put in a repeat value when you put in the union. You get me? So the union of Q and S, let me put up here. I'm doing the union of these two. You cannot repeat any value. So it's a 2, then a 3, then a 4, then a 5, then a 6. That is the union of Q and S, right? Now we're doing that intersection with P now. And P is what again? 2, 3, 5, 7. And here now we're looking for the intersection between these two sets now. That and that. Let's underline them. So you have a 2 in this and a 2 in this. You have a 3 in this and a 3 in this. You have a 5 in this and a 5 in that. That is it. 2, 3, 5. So the answer is 2, 3, 5. Yes, C. But that's not working out.
Yes, sir.
Yes, sir.
The union is first. And then work the intersection on it. All right. That finishes this first page. You're going to do some questions today. I'm not doing all of them here. Down here. It's a question from a past paper. It says P are prime numbers, Q are odd numbers, and R are even numbers. Which of the following is a empty set? Look here, empty set can be written with this symbol as well, right? You know that, right? That's a symbol for empty set as well as this. Empty set. All right. So, which of these is an empty set?
So Q intersect R.
Q intersect R. You said Q intersect R. That is true. Q and R. Q intersect R. Right here. Why is that? Because no odd number is also even. There's no odd number and even numbers are in what we call disjoint sets, like this. If I draw the set diagram for these two, they'll be disjoint sets. So I put in set Q and I put in set R. There's no intersection, but there's no odd number that is also an even number. Don't it? Is there intersection between these two? Prime number and odd number.
Yes, sir.
What the prime numbers are? Majority of them.
Yes, sir.
Yes, sir. Majority of them, sir.
Between these two. Prime
Yes.
number.
So as long as 2 is there, it's there's an intersection because 2 is a prime number.
Who is the only even prime number, right?
Yes, sir.
Only even prime number. Remember also that 1 is not a prime number. 1 is not a prime number. But a prime number must have two different factors. 1 and itself. Get me? So 1 is not a prime number. The first prime number is 2, which is the only even one. 2, then 3, then 5, then 7, then 11, and 13, and so on. Starts at 2. So 2 is the only even prime number. All right, let's just make mention of those things as we go. So these are what we call disjoint sets. Just in case they ask a question, which they do, they ask us about disjoint set sometimes. Disjoint, that's the word that they use. Disjoint. Meaning that there's no intersection. All right. Just like when you flip a coin and get a head or a tail. You can't get a head and a tail. There's no intersection between a head and a tail. When you flip a coin, it's either get a head or you get a tail. So you're putting those in sets, those again will be disjoint set. All right. Next example down here. All right. So the thing is, what does this symbol mean? What is that symbol? This one right here. What does that symbol mean? How you say that in words? So this one is for is a member of. That is a member of. Is a member. Oh, that's why you say that one. This one is a subset
Yes, sir. Subset.
of. So this means is a subset of. So in this case, this is B is a subset of A. Look at the symbol. What does this one mean? We turn it that way. Turn it that way.
A
Sir.
is a subset of B.
The thing over here, so, is a subset of the thing. It's like you read it the other way. So it's like this, read it this way. This over here, so is a subset of over this. For example, A is a subset of B. So let me shift this over. This should mean that A is a, I mean, it's P and Q. This one would mean P and Q. It would mean P is a subset of Q. But write it this way now.
Would be Q is a subset of P.
This would mean that you read it the next way. Q is a subset of P. Or you can say P contains Q. So this means contains. P contains Q. P contains Q. I read it this way. Q is a subset of P. That's why P contains Q. Q is inside of P. That's what it means. P contains Q. That's what this one, we turn the symbol out the other way. I'm supposed to have this. And I cross it like that. What does that mean?
It's not a member.
Not a member. And if I have this one, and I cross it like that, same thing. Not a subset of. Get me? When you cross it, it means not. All right. So we're ready for this question now. So this is just information, guys. This is just, as we go through, I'm just reminding you of some stuff, right? We don't know what's coming in the exam, so I'm reminding you of the stuff as we encounter them. I already know. So A is this set, and B is that set. So which of the following is true?
Yes, sir.
You say B is
Yes, sir.
yeah, because this, and this, two of them in there. So that, so B is a subset of A. So the A is correct. This is correct. All the elements in B are inside of A. So B is a subset of A. All right. This one, somebody do this one for me. So the universal set 1, 2, 3, 4, 5, and H is 3, 4, and 6. What is H complement? Somebody write that up for me quickly.
Say 1, 2, 5.
1, 3, 5, sir.
Somebody say 1, 3, 5.
1, 2, 5.
Somebody say 1, 2, 5. Somebody else?
Yeah, 1, 2, 5, 1, 2, 5, 1, 2, 5.
Not in H, but it's still in the universal set, right? You see it here? So these are the values that we have identified so far. 3, 4, and 6. 3, 4, 6. So these are the values then that would have to be in H complement. So this has to be 1, 2, 5. Complement means what is not in H, but still in universal set. What is not in H, but still in universal set. So it will be this one. The fast and good? Nice and easy. Nice and easy. This one now. Similar question. Let me make this a little brighter for you. Let's put the blue on it. So this is 6. Less than or equal to this is X. This is less than, and this is 10. Question says the elements of the set. This is X is such that. So that's what they give us. X is such that. And I say, which are these? Which are these is this? Which are these?
6, 7, 8, 9.
So 6, 7, 8, 9. Anybody else? Can I give that? Because this equal
Yes,
only
sir.
including the 6. This less than alone means that you're not including the 10, right? And you want integers, meaning that you want a whole number. So you're including the 6, but you're not including 10. So you go from 6 to 10, not including the 10. So 6, 7, 8, and 9. All right. All right, this one. All right, don't answer, just work it out and tell me what you get. Don't answer it aloud. Which one of these is correct? So P is this, M is this, N is this. Which of these is true? And here now is one we might use a process of elimination to see which one is not true. Work it out and tell me what you get. Which of the statement is true? M is a subset of N. So when I say M intersect N is equal to N. So when I say M union N is equal to N. So I say N intersect N is an empty set. It's a process of elimination. Which one is true? Somebody tell me now. Which one of them is true? It's asking us for which one is true.
Say me.
Somebody said B. Anybody else? Anybody else?
B, sir.
All right. So look here. If you look at this, the P and the Q are inside of here now. So if you were to write the intersection, because this one is not true, because this one is saying M is a subset of N, which is not true. Because M bigger than N in any case, so it could not be a subset. But I go to that. So this one is not true. You use a process of elimination. So this one out of it. But this one is saying no, M intersect N is N. What is M intersect N? M intersect N is actually the intersection P and Q, Q and Q. So this is actually P and Q. And this P and Q is actually N for true. See that? So the answer is this one.
Yes, sir. Yes, sir.
Yes, sir.
Right. The rest of it is not true. All right, down here. Which of the following pairs of set is an example of a disjoint set? Come, don't shout it out there. We are to second. Think about it. Which one of them is a disjoint set? A, even odd on even numbers and odd numbers, B, multiples of 2, multiples of 3, whole numbers and rational numbers, multiples of 5 and multiples of 10. Which of them is an example of disjoint set? Remember, disjoint sets are set with no intersection. No that is common to the two sets. What the answer? Someone tell me the answer now.
Sir, A.
A.
Good. A is the answer. But no even number can also be odd. So these two be disjoint sets. You know, disjoint sets are sets with no intersection. They are two separate sets. Two separate sets. There's no intersection. All right. Here's a question of percentage. It says all students in a class play Scrabble or checkers or both. I advise you, a question like this, you can maybe do a little quick Venn diagram. And because this is expressing percentages, remember the total percentage in your whole Venn diagram must be 100. Give you a minute to do this one and tell me the answer. What percentage of students play checkers but not Scrabble? Also, just like a draw a Venn diagram, put on the numbers on it and see what is happening. Come on, quick and fast.
48.
Somebody said 48. Who play checkers but not Scrabble? Draw a quick Venn diagram, put on the values, but the total must be 100 because it is expressing percentage.
$48, sir.
Yeah, somebody said 48. Anybody else? So a question like this, if I were you, I would do it like this. Just to make sure. I know everything must be 100%. I'm putting in the subset for Scrabble and for checkers. All right. So Scrabble, this one says all students play Scrabble or checkers or both, right? So there's nothing out here. That's what it basically say. They play checkers or Scrabble or both. Mean that there's nothing out here. That's a start. Then it says 36 play Scrabble only. So make this be Scrabble. Make this is checkers. I'm gonna put 36 here. Play checkers only. And 16 play both. 16 play both. I'm gonna put 16 in here. And it says now, what is the percentage of those who play checker but not Scrabble? Talking about here, so. See that? So we're working out this value right here. Let's call it X. The total must be 100. So 36 plus 16 plus X must be 100. And so the X is add up these two much again. 52
52, sir.
plus 100 minus is 52. That's why the X is 48 for you.
48, sir.
48. That is the answer. There's another question somewhere near with the same information, but I have something different. Let me see if I can find it. Hold on. Same information. Scrabble checkers and see if it is there somewhere. Hold on. Here. The same exact question. See? Same question, but this time I give you the 48 in this one. See that? This time I give you the 48 in this one. Go on now. What's the answer for this one?
16.
16.
Switch on the question. See? Switch on the question. Same information, and that's what CSEC does. They switch around the value sometimes with the same question. Right? So what was the answer for the previous question? Is now a part of this question. And what was in the previous question, now the answer for this one. So if you're working it out again, so you have to understand what you have to do. So if you change it on here, you can still get it. Okay? They can still make another change again. You know? Now can actually change out even those values and just change up everything altogether. Instead of talking about checkers and Scrabble, they might talk about football and cricket. Right? So Scrabble and checkers, 36 play Scrabble only. Another question might say 36 play Scrabbles. If they say 36 play Scrabbles, it's a combination of here and here. They don't put the word only on it. Get me? Only means inside here. If there's a 36 play Scrabble and don't put the word only, it means that the sum inside here, so it's 36 here and here out of the 36. Look out for that. All right. So because it's 36 only is here. There's a 48 piece checkers only. That's 48 is over here. So this thing I'm trying to find inside here. Play both. Want to know play both. So the same thing. Everything must add up to 100 again. So 36 plus X plus 48. But this percentage must equal 100. Add up these two and subtract, we get X equals 16. That is it. All right, let's go back up here now. Let's go back up here. Come, guys, I want you guys to get some paper. Get some paper and do some work, man. Hello, mom. Sit up. Get some paper and do some work, man. Come on. It's not me working out all these questions. You're doing some of them as well. Got this question over here on this side now. It says, refer to the two intersecting Venn diagram. It says, in the Venn diagram, number of use the number of play games, H a number of play hockey, B a number of play volleyball. How many students play either hockey or volleyball, but not both?
9.
Hockey or volleyball, but not both. When you work out this one, you see the R? The R means union. Means union. The R, and it's the inclusive R. It means hockey or volleyball or the both of them, but they want not both. So it means that this is the one that don't play both. Hockey or volleyball or but not both. What is the answer for this one? Or usually means that you're gonna add them up.
9.
So if you're talking about these and these only, see that? That you don't want those who play both. So the R by itself would include both of them. So if the question was just how many play hockey or volleyball, and stop right there, so. And don't put in the but not both. It will be everything in there. You get me? You understand that? But by them saying not both, it means that they're taking out the both. So it's just the 5 and the 4, make the 9. Now, on another exam paper with the same Venn diagram, and then I ask this. The number of students in each set, the number of students in each set is indicated. Okay. How many play exactly one game? Same Venn diagram, but now they're asking how many play exactly one game. What's the answer for this one? How many play exactly one game? Somebody answer now, how many play exactly one game? The same answer. One game, one
9.
game.
9, sir, 9.
Answer. See that? Same question, but a change how they ask it. Alright? 9. How many play 2 games? How many play 2 games? 2 in that section here, sir. 2 games. If you ask how many play 2 games, it will be this. How many play no game at all?
3.
3.
3 or 3, sir. So the answer for this one is also 9. Talking about the same. So this kind of same question, but change the wording of it. Same Venn diagram again for this question. All right. Down here. It says, set up 2-digit positive integers that are divisible by 7. A number that is divisible by 7 is a multiple of 7. Know that, right?
Yes, sir.
Is an example of an improper set, an infinite set, an empty set, or a finite set.
Finite set, sir.
So him say finite set. Anybody else? Anybody else? The set of 2-digit positive integers that are divisible by 7. Never said, never say number that are divisible by 7. It said 2 digits. It must be a finite set. It's like you start at 14. 14 is the first number that is divisible by 7. If a number that is divisible by 7 means it's a multiple of 7, don't it?
Yes, sir.
A multiple of 7, but you don't want the 2-digit ones. You're not going over to the hundreds. You get me? Has to be a finite set. So it's 14, then 21, then 28, and continue all the way up until you reach the last one before you reach 100, which is what? I think it's 98 is the last number.
98, sir.
So, don't it? That's a finite set. What's the difference between a finite set and an infinite set?
Infinite is a continuation where you don't have any ending. It goes on and on.
Goes on forever. It
Does
doesn't
not terminate. An infinite one does not terminate. A finite set has a set number of values in it. It terminates. It ends. It has a set number of values. An infinite set goes on and on and on forever and ever. Amen. So all they wanted was just they didn't put in this term in there and said they wanted 2 digits. If all they wanted was the positive integers that are divisible by 7, then that would be an infinite set. Okay, I can keep multiplying by 7 forever and ever and ever. Amen. That would be an infinite set. All right? They didn't put this term. So you can look over the same question without this term in it, you know. They take this out of it, the answer is going to be an infinite set. But this time, it's a finite set. This one is a finite set. So another question down here. The set of positive integers
C.
divided by 6.
Infinite.
infinite.
This one now is infinite. See? Same thing we just discussed about the 7. Same thing I was saying. The positive integers that are divisible by 6 now. That one is infinite. I can keep multiplying by 6 forever and ever. Amen. So this one is an infinite set. Never ends. All right? Never ever ends. This one here now. Item 9 and 10. So there are 2 questions relating to this Venn diagram. Let's look at the first one. So it says The universal set, there are two sets T and C, represent students in the class who play tennis T and chess C. How many students play both games? How many students play both games in this question? Somebody said 2. Anybody else? How many students play both games?
2.
Yeah, the people inside here, they play chess, but they're also within the tennis. Just like the chess is a subset of the tennis. So everybody who play chess also play tennis. You see that? Everybody who play chess also plays tennis. There's just these two persons in here. So the answer is 2. That's Paul and Rima. Play both games. They play chess, but they're also within the tennis subset. So they play both games. It says, how many play exactly one game? How many play exactly one game? 4 people play exactly one game. 4 persons play exactly one. Let's color code it. So these red ones are the ones who play exactly one game. Nothing. 4 of them.
4.
But I hear that?
Yes, sir.
Good. And how many people play no game at all?
3.
3, sir.
Persons play no game. 3 on the outside game. All right. Come answer this one for me. That Venn diagram shows the number of members in a club who play rugby and basketball. The number of members who play rugby but not basketball is what?
10.
50.
Somebody said 15. Anybody else? What do you say? Those who play rugby but not basketball. Huh?
15.
Yes. Rugby but not basketball. That's 15. That's pretty obvious. Wanna go? All right.
Yes.
Next one. The number in set A is n. Then the number of subsets A can be expressed as, which one is the answer? The number of elements in set A is m. Because the number of subsets can be expressed as what? In other words,
Sir.
number of subsets. Which one?
A.
A. Remember, the number of subsets is 2 to the n. Just like this time, the n is m. The answer is this one, 2 to the m. Are you good at that? That's all.
Yes.
That. All right, 2 to the m. Don't give it away. Next question. If Q has the elements A, B, and C, how many subsets can be obtained from Q?
D.
Huh?
D, sir. Same
D.
thing with just now. D.
Sure. But I give it that. Because the number of values in this is 3. So it's 2 to the n, right? 2 to the n, where the n is equal to 3. So the answer is this one, right? But I write that.
Yes.
All right. The set of positive integers is an example of. Set of positive integers is an example of.
Infinite.
Infinite.
Anybody else?
So that's the answer.
Huh?
That's the answer, infinite.
What I give that is infinite.
Yes, sir. Infinite.
Yes, sir.
All right.
Infinite.
That's pretty obvious. Beautiful. This one down here. What's the answer for that one? The number in A is 14, number in B is 15, number in the union is 25, number in the intersection is 6.
23.
This is the universal set. What's the number in the union? Somebody said 23.
23, sir.
Same question, let's flip it around again, right? So these two are to 29. So these two must also add to 29. So if this is 6, then this is going to have to be 23. But I get that? The answer is this one, 23. This one now. P and Q are two sets where the union is 13, intersection is 6, number in P is 9. What is the number in Q? Huh? 10, who said 10? Somebody else? Somebody else? What you said? You said 10, what you said? You said 10 too? What you said? Zara, what you said? Huh? 10. Correct. So remember, them 2 here, same thing again. Same thing again. The sum of the union and the intersection must equal the sum of the P and the Q. Them 2 here. So them 2 here up here, so add to, what is that, 19? So them 2 here must add to 19 too. So those 2 must add to 19. Then this have got to be 10. This has to be 10. Because 10 and 9 is 19. So the answer is this 10. Simple as that. All right, good. I can get in the picture now. All right, anything else over here? Same question again. Got these. Come read these out for me quickly. Work out this one and this one for me. X and Y are 2 finite sets. Number in X is 9, number in section is 4, number in is 15. What's the number in Y? Down here, so now it's basically the same thing. Number in X is 9, number in Y is 10, number in unit is 15. What's the number in the intersection? Come tell me the answer up here, so first. What's the answer up here, so? Quick and fast.
10, sir.
Huh?
10.
10. But these 2 add to 19 right now, right?
Yes, sir.
These 2 must also add to 19. So this is going to have to be 10. This is going to have to be 10 for those 2 to be 19. What about this one down here? What's the answer down here?
4.
4. All right. So these 2 add to 19. So these 2 must also add to 19, right? So this therefore has to be a 4. Because over here so it's 15. All right. This one, the Venn diagram shaded region represents what? The shaded region is what?
P intersection. P.
A,
Sorry, P complement.
Complement
A,
of shaded region is outside of P, don't it? P
yeah,
complement. See that? P complement. Nice and easy. What about this one? The unshaded region is what? The unshaded region is inside here. What is that?
Q no, that's not Q.
C,
Q
sir.
only.
C, sir.
Two only, which is
Let's see.
C, sir.
Sir, C at the answer, sir.
is the answer.
Yes,
P
sir.
and Q complement. Mhm.
The question is asking you for the unshaded region, which is inside here. That's what we're asking you for. This guy asking you for Q only. That's what the question wants. Q only. So Q only can't have complement on it. It can't be this and it can't be that. If you want Q only, or you gonna put complement, you have to put the answer with the complement on it. When complement means outside of Q. The answer can't be, the answer cannot be, the answer cannot include something out of Q if it's Q only you want. The answer is this one, is Q intersect P on P complement. This means that you want Q, but you don't want a P.
I did answer that.
And not P. So you see, you're in a Q, but you're excluding the part of P that is in Q. You understand that? That's what the complement and the P mean, you know. Right? So it's Q and not P. So it means that you're excluding, the not P means that you're excluding the part of Q that has P in it. So this is the answer down here. That's Q only. Question never asks for the shaded region, it asks for the unshaded. If it asks for the shaded region, what would it be? It would be the complement of this, really. That's what it would be, the complement of this. That's what it would be. All right? All right. Let's continue. Down here. Which of the following is equivalent to this set? Which one is equivalent to that set? Which one?
C.
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 Looking for one that has the same number. Equivalent sets have the same number of elements. Same number of elements or same number of members. Same number of elements. This is it. And this has 4 elements, this has 4 elements. But understand that. N equals must equal 4. We did this question a while ago. Down here now. Somebody work out this one for me. In the Venn diagram, stop talking. X represents the set of factors of 12. Y represents the set of factors of 9. Shaded region represents the set of all factors of. Come brother, turn on for me, please. Quickly, give me a minute. You only need a minute. And we need to do this question is to write out the set up, write out the set them and look at it. So write out the factors of 12. And write out the factors of 9. And then look what the shaded region is, which is the intersection, and see what it is. And then you can answer the question. Write it out. Don't just be looking. Write out the factors of 12 on the paper. Write out the factors of 9 on the paper. They look at the intersection and write out what the intersection is, and then you will know which one of these is the answer. Write them out. Come on. Huh?
I'll say A, sir.
Is it A the answer?
Yes, sir. I'll say that.
I agree with that.
So the section is 1 and 3, and those are the factors of 3.
X are the factors of 12, right? Start from 1, then 2, then 3, then 4, then 6, then 12, don't it? 12. Those are the factors of 12. Then Y. Y are the factors of 9.
1, 3, 9.
At 1, 3, and 9. Then the intersection, X intersect Y, which is what the shaded region is. The shaded region is X intersect Y. So we need to know what is in X intersect Y. So the values are here, 1 and 3. 1 and 3. So this set is 1 and 3. And 3 is a prime number of those 2 factors, right? So therefore, that represents the factors of 3. Very good? Nice and easy. All right, this one. So this question is a question that CSEC set this particular question multiple ways. This particular question, CSEC set the same information now different, maybe 4 different ways over the years. I kind of recent question, like maybe past 5 minutes started this question. Question says 30 students in teacher May's class have either a dog or a cat or none of the two. So she have dog or cat or none of the two. All the students who have a cat have a dog. All the students who have a cat have a dog. Once a year that you know say you have a subset thing happen, don't it? Don't it? All the students who have a cat have a dog. It means that you have a subset. Right? It means that the cat owners are a subset of the dog owners. All right? Which of the following Venn diagram below correctly represent this information? It is the process of elimination, you know. It is the process of elimination. Look, for example, this said the number in C is 12. Right now, this number in C is 14. That make it wrong. See that? But I can say that the number in C includes this and this, you know. So this right here, so now is 14. That makes that wrong, but the number in C must be 12, not 14. Let's look at the next one. So this one is, well, this one do have a subset thing happening. But this has shown two disjoint set.
Right, so that's out of it.
Right, but the information spoke about some intersection taking place, right? Actually, a subset taking place. That's why
Right.
this one.
All who have cat have dog.
Right. So this one have disjoint set, and based on information, we do have disjoint set. So that one out of it. Look about this one now. This again out of it because this is 14, don't it?
See what that.
So this again is out of it because this is 14 right now, and they said the number in cat was 12. So by process of elimination, you have gone through out of it. This has to be the correct answer. And it is true because I see it. All who have cat also have dog. See that? Cat is a subset of the dog. So that is it. And I said the number in the cat is 12, and the number in the dog is 16. Which is what I said. Did you so? 16. Number in the dog is 16. 12 in your sub dog and 4 to sub dog alone. Good? And so you have 16 of dogs. So that is the answer down there. So. And I said the same information and ask different things. There are questions done with the same information where this is the answer, or where this is the answer, or where that is the answer. Something different is the answer. And the information, the change information a little bit. But the same cat and dog business. Oh, so one right here, so as we speak. Look at this one. As we speak, here's one. 30 students in this main class have either cat or dog, or none of the two. Or none of the two, you know. While up here was or both. Look at it. Oh, none of the two as well. Cat or dog or none of the two. I think that was an example with none of the two. That's what I see. It says 16 students have dog, 12 students have cat, and the remainder have neither dog nor cat. Which Venn diagram below correctly represent information? This don't talk about no subset anymore. Which are the answer?
B. So this joint.
Huh? The disjoint. Why is it a disjoint?
It says 16 kids have dog and 12 have a cat and neither. The other one are neither. So it's a this joint.
Right.
All right, let me see it. 30 of that. It says a dog
16.
or a cat.
So 16 plus 12.
Cat or none. All right, a dog or a so like a disjoint for you.
I can pick it up to make sure.
Never say anything about both, don't it? A dog or a cat or none. It says it's a process of elimination, just to make sure. It says 16 have dog, 12 have cat, and the remainder have neither dog nor cat. Oh, so there's no both. Yeah, this is right. Let's just make sure. So 16 have dog. This is a process of elimination. So 16 have dog. This is a 16. And it's a 12 have cat, but it's a 14 in it. So this is wrong, right? But it's a 14 in it. Just using a process of elimination. So it's a 14 in it. So this is wrong. But it says 12. So this is wrong. Over here, so this has the dog. In this one, the dog is older than 28. Because you see the number of dogs, it's a 12 dog, you know. And plus 16 dog, you know. But they said there were only 16 dogs. So this is wrong.
16.
But this, if you add up the dogs, then this is this plus this, right? This one wrong. But this dog will be adding up to 28 dogs. And down here, it should be 18 dogs. It should be 18 dogs right now. And 14 cats. That wrong in both ways, but there were only 16 dogs. So yes, this is the correct one. So sometimes if you're not sure, can use a process of elimination. Like,
Joshua,
yeah,
could I ask one question for the previous one?
the previous one up here.
Yeah, the previous one with the four. I don't understand how you get D in a set, but I don't understand how the 14 outside.
Huh? Which one?
For the
Which one?
previous one, you think the one up top? No, the one up top. Yeah, that one. I don't understand how the 14 outside. Though.
I remember everything was out of the 30. Remember the total is 30 students.
Hmm.
So inside us you have 16 and 14 make 30.
Oh, all right. Sir.
Right? Remember the question start and says 30 students. Here, 30 students. Everything was out of the 30. So I'm going to put 14 out here. And the inside it says 16. All right, 16 students now.
Yeah, sure, I get it.
All right. Next one over here. Which other Venn diagram is this? A intersect B complement. Which of them is that? A intersect B complement.
What's a B?
Yes, that is correct. Because this is the set notation for A only. You know, somebody tell the Tony to go outside. No one talk on go outside now. This is set notation for A only. A intersect B complement. So that is this one. A only. It's shaded. All right. Consumer arithmetic time. Sets done. Want to take a short break? What time is it? 12. We can do about 3 topics today. What time is it about? 2 o'clock? 2 o'clock? All right. Let's take a little short break. And then we'll come back and do some consumer arithmetic. Consumer arithmetic, a lot of questions there. Consumer arithmetic is a lot of questions. A lot. We don't know somebody. All right. We'll take a short break. And then we'll come back and we'll do some consumer arithmetic today. And then maybe another day we'll do another topic, right?
How long, sir?
We're going to take what, 15 minutes? No more than that.
Okay.
And put up the clock. I'm going to put up the clock for 15 minutes.
Sir, which other day we are doing this again?
Huh?
Which other day we'll be doing this?
Which day?
Which other day, yeah?
I don't know yet. Maybe tomorrow or in the week. I'm not sure.
All right. Either way, just send out the notification. I go.
Yeah, I do. Yeah. 15 minutes. We're gonna have 2 minutes on fire. Right.
Excuse me, Mr. Shaw.
Yeah.
Do we have class tomorrow?
I think, but I think I'm gonna do another session like this tomorrow.
Okay, sir.
Yeah. Come on, close the door now. Let's go. All right, guys. So with these questions, I want to give you like a minute to do the questions. Remember, you can't use a calculator, you know, so you have to be able to work these out without a calculator. First question here. It says for every $100 sales or part thereof, for every $100 sales or part thereof, in other words, anything less than $100, a salesman is paid $10 as commission. So therefore, if him sell $110, for example, he might get $10 for the first $100, plus he might get another $10 for the $10. So you get $20. But that's on that. All right, let me give you an example. If him sell $150 in sales, for the first $100 he's getting $10, right? Then for the $50, he's also getting another $10. But that's on that. For every $100 or part thereof, he's getting $10 of commission. You understand that, right? So for example, again, if he sells, suppose he sells $220. $220. Suppose he sells $220. For each of the $200, he's getting $10. So that would have been 2 times $100 plus $20. That would be sales. So his commission would have been 2 times $10 here, so plus another $10 over here, so that would be his commission. Understand that now? For the $200 that he sold up here, he's getting $10 each. And then now for the additional $20, he's getting another $10 for every $100 or part thereof. So every time he reach $100, he's getting $10. And then now for any part after that, no, he's getting another $10, right? He's paid a commission of $10. All right. So it says, if it says for a particular amount is this, how much commission was he paid? So you want to know how many whole $100 is in that? That $1,020. You want to know how many whole $100 is in that? Because you're getting $10 for each of them. And then clearly there's a part of 20. He's also getting $10 for that part of 20. So what will be his commission? I'm giving a 30 seconds to work it out. What will be his commission for that one? What will be his commission? So I see how many $100 is in that $1,020 plus he's getting also a commission for the $20. How many whole $100 is in that? Answer the question. I'm looking at my clock. Come on. Anybody? Okay, all these questions that I'm working out and I've heard them over again. Because you have to be able to do the question. Watching me do it is not enough. You're always gonna understand and stuff when I do. You have to go and start over by yourself. So what you want to know is how many $100 is in this? Whole. So this $1,020 is the same as $1,000. It's the same as $1,000 plus is $20. Why did I do that? Because I want to get a number that's a multiple of 100. So this has 10 100s in it. That's 10 $100 in this. Plus this $20. That's his pay. For each of these $100, you're getting a commission of $10. So I put the commission in red. This is 10 times $10 commission. Plus he's getting a commission of $10 for that $20. That's a part they up. Getting another $10 commission over here. Understand that? So this 10 times 10 is $100 here, so commission. Plus another $10 commission over here. That's $110 total that he's getting. $110. So the answer is this one. Understand that, guys?
Yes, sir.
So first you have to do is understand the statement up here. For every $100 of sale, that says or part thereof. Means if you don't reach another $100, they're still gonna give him a commission of $10. So if he sells $90 of goods for a day, you get a commission of $10. That's a part of 100. But if he sells $130 of sale for a day, it's the first $100 that he sold, he's getting $10 for that. And then for the additional $30 that he sold, he's getting another $10 for that. Because it says for every $100 or part thereof. So every time he sells $100 worth of stuff, he's getting $10. And then if he sells an additional amount, but he don't quite reach another $100, he's still getting another $10 for that. Understand that now? So if he sells this amount in a day, the first objective is to know how many $100 is in this amount. So I take this amount and I break it down into $1,000 plus $20. Because I want to find a figure that has a certain number of $100 in it, which is $1,000. You get me? So this $1,000 means that he would have sold $100 10 times. He would have sold $100 of goods 10 times to reach this $1,000. And then after he do that $100 10 times, he did an additional $20 of sales. For each of the $100, so this 1,000 means that he would have sold $100 10 times, 10 times 100. For each of these $100, he's getting this $10 commission. That's why he got $10 10 times. Then for this $20 sales, he's getting an additional $10 as a part thereof amount. Understand that now? So the total commission then is 10 times $10 for the $100 that he did, plus he's getting an additional $10 for this $20 that he did. So the total commission is $1,110 commission. Understand that now? My question like this, I have to go work it over back because the CSEC can change the numbers on it. And you have to be able to work it out. It's not just memorizing the answers, guys. You have to be able to work it out. There are 8 consumer arithmetic questions on the paper. If you get them wrong, you have 4 below the number you have to get right in the exam. Remember, say, we don't want to get less than 58, you know. And there are 8 consumer arithmetic questions on the paper. On the upper master of the consumer arithmetic. 8 of them depend. You can't afford to be getting them wrong. Next one. This one says, the value of a plot of land is $18,000. That's the value of a plot of land. Look here, let's have to just Don't just look at the numbers, you know. Just think of it in a realistic way. Just visualize realness of it. You have a plot of land and the value of it is $18,000. Land tax is charged at 70 cents. That is 70 cents, you know. $0.70 is 70 cents per $100. Means that for every $100 in this, for every $100 in that amount, you are paying 70 cents. Good? Question says, what is the total amount of tax paid? Come, try it for me. So what first you have to do is find out how many $100 is in this. By divided by 100. And then multiply it now by the 70 cents. Because for each $100, you're paying 70 cents. For each $100, you're paying 70. That's what this means, you know. 70 cents per $100. So every $100, for every $100, you're paying 70 cents. So you want to know how many $100 is in this. So you divide it by 100. And then multiply it by the 70 cents. Now look here, a question like this, we can know the answer for a question without doing anything, you know. Why? Because I have to go multiply that 7 here by the 18 or so. And 7 times 8 are 56. The only answer with a 6 down here, other one, that have to be the answer. The only answer with a 6. Because I have to go multiply the 7 by the 18. So I have to go multiply the 7 by the 8. 7 is a 56. The only answer down there with a 6 in it is that one. 1 6. You must know the answer. So it has to be that answer, that one is the answer. So a lot of the times, not everything in the exam you have to work out. Just be smart. That's why I said to you at the beginning of the class, the answer is on the paper. So when you read the question, you look at the answers. And sometimes you can see which one it has to be. It has to be the one with a 69. Because 7 times 8 is 56. You're going to have to multiply this by the number at some stage in the calculator. And you multiply the 7 times 8, you get 56. You must get that a number will end with 6 as a part of the answer. Must. All right, so basically, the calculation would be, you want to know how many $100 is in this. So it's 18,000, sorry, divided by 100 to know how many $100 is in this. And then for this, tell you the number of $100. And then for those number of $100, you are multiplying each of them by this to get the tax. 0.70. That is the calculation. That is the calculation. Those are some cancel down business. All of our zeros are about the place. Some cancel down business now. But as I said to you, the substantive number that you're multiplying is this 7 and this 18. Those two numbers are what are going to give you digits in the answer. Because all these other zeros is just this going to tell you how many decimal places there are. That's all it's going to tell you. That's all that's going to do. They're going to cancel down and tell you how many decimal. But in terms of the digits that you get in the answer, it's going to be the 7 times the 18 then. And 7 times 18 are 126. So this is the only answer with 126 now. That have to be the answer. Or you get 7 times 18 is 126 speaking at the exam. Because I said 7 times 18 is same as 7 times 10 plus 7 times 8. Okay, you can't use calculator. 7 times 18. You want to set it up and do 18 times 7 and do all of that, then fine, no problem. But you're going to have to multiply the 7 by the 18 to get the answer. Right? It's not everything you have to work out in the exam room, guys. But if you want to cancel it down, now what to that? Look at that. Look at it become 7 times 18. Them 2 0 here cancel them 2 0 there, so don't it? That's all. You see that 0 upon a 10, that's up on a 180 there. You move the decimal one to the right. That's what it does. That 0 here on that 180. Same as 18 times 10, you know. So that 0 here, move the decimal point and put it there. So it becomes 18 times 7 in the end. That's what it boils down to. 18 times 7. Simplify down to that. And that is 126. Simple as that. If you can work 18, you can work 18 times 7 like this if you carry the calculator. 18 times 7, traditional way. Right? 7, 8 is 56. 7, 1, 7, and 5 make 12. See there, 126. Or you can go shortcut. 18 is the same as 10 plus 8. So it's 7 times the 10 plus 7 times the 8. This is 70, and it's a 56. That add to 126. Anyway you want it. Because you cannot use calculator. So you have to do this calculation. You have to do it. That's why add maths is easier than CSEC maths. Because in the add maths exam, they can use the calculator and it's only 45 questions. I'm telling you. No, the question, a lot of the questions in add maths are numerical questions. You can't use the calculator anymore. But anyway, I'm telling you, it's true. But go to that. So come 18 times 7 is 126. Hey, I'm about to start that. I'm about to start. This one says,
Sir.
yes? Have a question?
So, sir, the AdMax is the same procedure that with the registration for CXC, CSEC.
Yeah. There's another
Same
stuff.
cost and them something there. SBA or it doesn't include an SBA.
Yeah, same. It's another CSEC subject.
Okay.
Another CSEC subject. Ready? If the simple interest on $900, so it's a simple interest question. Remember, the key for your simple interest question is this.
Principal.
Was PRT divided by 100. The important thing to remember here is that the time is in years. The time is in years. Why? Because the rate is always a rate percent per year. And if the rate is 5%, then the R is equal to 5 because the percent part of the rate is already taken care of by that 100 and a year. So the rate is always expected to be as a percentage. That's why the 100 is under there. All right? That is the formula. And remember, this formula is not only to find interest. Because some questions, they will give you the interest and give you 2 of these over here and ask for one of them. So it's not only to find interest. Sometimes you know the interest and you're trying to find either the principal, or you might want to find a rate, or you might want to find the time. You have to transpose to make the one that you want, the subject. So you don't write a formula like this, it is not only to find the interest. You transpose this formula to find what you want. Now that's what the question says. It says the simple interest on $900. So basically, this question, this $900 is the principal. For 3 years, this is the time, T. Was 108. This is the interest I give you right here. What is the rate of interest? So this question is asking you for the R. See? It's asking us for the R. I put it in red. So it is the R we're trying to find in this question. What is the R in this question? That's what it is. So you basically want to make this R the subject. You want to make this R the subject. So you transpose everything away from the R. Or you transpose from the R. You take the 100 and you multiply it up here. You take the P and the T and you divide them under. And leave the R alone as a subject. So see here, the R becomes multiply by 100 times the interest divided by the principal divided another year, so which is the P, and the time divided another year, so which is the T. That's what you're gonna make R the subject. Then plug in those values now and simplify. So all that. All right, so let me make this a little bit smaller and work it out. All right, so it's 100 times the interest of 108 divided by the principal of 900 and the time of 3. That gives you the rate. That looks like, what is the answer here, sir? Just simplify this down. Simplify this down. So if you know the times table, you know, guys, you can't get to any. So this 100, cancel this 100 right here, so. right? This is 9. 9 into this is how much? 12, don't it? No, sir. Yes, sir.
Yes.
And then divided by 3 is 4, don't it? So it's all work out to be 4. So the answer is 4. Just cancel it down, guys. Up to 9 times 3, you can't get away from that. You can't get calculator. Example. Next one. So one here, just so this guy same question. See, same question now. This time they ask for, they give you the rate and asking you for the time. So the answer for this is going to be 3. The same number, them, you know. The same 900 principal. This time they give you the rate of 4%. The interest is still 108. So you say the time is going to be 3, the same time for the question a while ago. Right? And that's what CSEC does. They use the same question and just change up stuff. But it's not a new question, they just rearrange the same question. So the same thing again, we do it. Start with the formula for simple interest, which is I equals PRT by 100. This time it is time that we're trying to find. See, what is the value of T? The time that we're trying to find. So you transpose everything away from that T. Multiply the 100 first, you're going to get 100I. Divided by the P and the R. Divide the P and the R under here. The P and the R. That leaves you with the time as a subject. Then put in the values and simplify again. 100 times the interest again of 108 by the principal again of 900. And this time we know the rate is 4. That's what we're doing this time. That gives it a T. So the same calculation again, just simplify. Cancel that 100 here with this. 19 goes 1 time, 19 goes 12. See that 12 divided by 4 is 3. This equals 3. So that's this one. We have to know how to do it in case CSEC change the numbers or just give the information another way. All right, another question right here. This one says, at the end of any year, a car is worth 5% less than it was worth at the beginning of the year. So what's mean now, guys? If it's worth 5% less, then the value is now 95% of what it was. 5% gone. You do have to work with the 5%. The remaining value is 95% of what it was, because 5% gone off the value. If it's a question with a piece of land appreciating by 5%, then the new value would have been 105% of what it was. You don't have to waste time working with the 5%. If something drops value by 15%, for example, the new value is 85% of what it was. Work with the 85%. If something increases in value by 15%, the new value is 115% of what? Of the original figure. Easier to work with the new figure percentage rather than working with the 5%. So here, it is 5% less than it was. So the new value is 95%, or 5% gone off the value. It says, if the car was worth 9,500 in December 2016, then the value in January 2016 is what? So it means that 95% of the original value is now this. That's what it means, you know. 95% of the original value is now this. So this is what it works in December, you know. So these are the final value. That value is 95% of what it was in January. So to set up an equation like this, to solve a question like this, you can say 95% of the original value in January is equal to this that they tell you that it is, 9,500. And try to find this January value. 95% of the January value is this December value. I'm putting in J for January. 95% of the January value is this December value. This is the December value. This is the December value right here. This is the January value you're trying to find. That is it. And 95 and 95 cancel each other. So the answer is 10,000. If you set this up and write this as 95 over 100. 95 over 100 times the general value is 9,500. See that? You take that 100 here and multiply it up here, so and take that 95 and you divide it to get the general figure. Simple as that. The general figure from 9,500 multiply by the 100 here, multiply by 100 here, get 100. And you take a 95 and you divide it under to leave the general figure as a subject. And you're good to go. See that work out to 10,000. Because a 95 cancels into this one time, so you get 100 here. So 100 times 100 is 10,000. Means already. So 95 into this goes 1 time, 95 into this goes 100 times. 100 times 100 is 10,000. 100 is 10,000. This is the answer right here. But go to that. Come on, I do too much of them. I'm not going to do them anymore. I'm not doing no more. I'm not doing it anymore. Come, you do this one. A man's regular pay is $3 per hour up to 40 hours. Overtime is twice. So if regular pay is 3, then overtime is 6, don't it? So we still do it. Twice. Overtime becomes $6 per hour. 6. Because it's twice. Twice means it's $6 per hour overtime. Right? Of the regular time. It says he was paid $216. That includes overtime, you know. How many hours overtime did he work? Huh? 8. All right, tell me how to do it now. You don't have to try it. So it's a 3 times 40 at 120. Huh? 2 bills, what is 2 bills? I get 200. Where's 200 from? 4 times she's 120. That's what I wonder you get 100 from. Come on, where the question? That's a joke thing, you know. That's a gimmick. Again. Get 16 hours. Everybody else? Come on, where the question? So just know that this figure, 216, it has the regular pay and the overtime pay. So what you need to do is subtract the regular pay from it to know what the overtime pay was. Right? Subtract the regular pay from that total pay. That 216 is the overtime pay plus the regular pay. So subtract the regular pay from 216, and that will leave overtime pay alone. Then take the overtime pay and divide it by the overtime rate of pay, which is $6, and that's the number of hours. 16 again.
16, sir.
No, you can't divide the 216 by the 6. But the 216 includes the overtime, the regular pay.
Sir, I would have to take away the 120 from 216, you get 96 and divide that by 6.
Right, that's what you have to go do. All right, look at the reason behind it. Pay attention. Guys, you know, work them question over, you know. Stop joking, no, man. You pack up and go me hard, you know. Look, the regular pay plus the overtime pay is what is equal to the 216. The regular pay is 120 plus the overtime pay equal 260. But understand that. Why is the regular pay 120? 3 times 40. So the regular pay up here, so is 3 times 40. $3 times 40 hours. That's $120. You get me? So you're going to subtract the 120 away. So where you get? Overtime pay is $96. And this is the overtime rate of $6 per hour. So overtime pay is $96. And so the hours, the overtime hours, I'm right, OT hours.
Divide by 6.
Becomes $96 overtime. About $6 when you get for each of them hours there. And that equals 16 hours. But understand that?
Yeah.
16 hours. All right, so another one here. Come do this one. A man's regular pay is $8 per hour, up to 40 hours. Same question, but different numbers. You know? Same question, but the value is different. So a man's regular pay is $8 per hour, up to 40 hours. Overtime is twice again. It says if he was paid $480, how many hours of overtime did he work? It's the same question, the value is different. You have to learn to do the questions. They will just change the numbers in the questions. And I'm going to try to see the same question. I same question, just the values change. So you have to know question. What again?
A.
Huh?
Okay, A.
Yeah, you're number boss. A. Oh, A. Everybody get A? Get A too? All right, let's work it out. So the regular pay is what? 8 times 40, right? Don't it? The regular pay is $8 times 40 hours. Which is how much? What is that?
220.
20. So the overtime pay is the total pay minus the regular pay, don't it? It's a 480 minus the 320. The dollar sign on it, Mr. Shaw. What is your work out to? 160?
Yes, sir.
Yeah.
Now, if this is a regular rate, the overtime rate is twice that, which is 60, don't it?
Right.
16 and then this one is 65 by 16.
So the overtime pay divided by 16 give it 10. That is correct. So the overtime hours from the overtime pay divided by the overtime rate of pay. Which give you 10 hours. So the answer is 10 hours overtime. All right, good. Next question over here. Easy, simple interest again. Come on, do this one and tell me quick what the answer is. Simple interest on $600 for 2 years, 5% per annum. What is the value of T? So they give you the T of the formula now. So you're transposing. You give the T of the formula, so you have to transpose. Quickly, which one is it?
I think none of B, sir.
B?
Yeah, I think so, yeah.
I want you to think, man. I want to work it out. Work
Yes,
it
sir.
out.
Yes, sir. B.
B again? Anybody else? So you start by saying I equals PRT divided by 100. And you're trying to make T the subject. All right? So you're going to multiply the 100 up here. You're going to get 100 times the interest. And then take the principal and the rate and divide it under here. So the principal times the rate under here. So that equals the time. You put in the values, 100 times the interest. Interest is 120. By the principal is 600. Than the rate. And the rate is 5, right? That's the time. So it is actually this one in truth, yes. All right, next one. Come on, do this one for me.
See, sir.
Like you swat the answer them.
Seven practice, sir.
Good. But more you make sure you read the question, them and make sure the same question. Because I might change a little thing for you, you know. Change the star to 50, I think the same question.
Yes, sir. Real.
Change the star 15. Yeah, man? Read the question, make sure you know what to do. Kind of straightforward. So this one says, at a bank, EC $2.60 is equivalent to US $1. So it's US $1 to EC $2.60, right? It says for every $1 exchange, 10 cents is deducted. So they deduct 10 cents, the exchange rate that you're actually collecting is 1 to 250, don't it? So you actually collect 1 to 250 US to EC, don't it? That's all. 1 to 250. So if you have $1,000 US, you have multiply it by 1,000. See that? You multiply by 1,000. That means 1,000 US. Multiply this by 1,000. That's all? No, 260. $2.60. $2.50. 2.50. Right, so multiply that by 1,000 again.
2000.
So this is the answer. All right. But after that, there's 250 you're collecting. Okay, got the bank keeping 10, right? 10 cents. Next one. A calculator which is marked 120 is sold for a cash at a 30% discount. How much change would Susan receive if she bought it for $100 with a $100 bill?
Sir, A, sir.
You say A. So again, if it is discounted by 30%, guys, you don't have to waste time and calculate the discount. You just want to know how much you're actually paying for it. She's actually paying 70%. She's paying 70%. So she's paying 70% times this. So right away, so you know, so you got 7 times 12. So 7 times 12 in a calculation is what? 84. That's all.
Yes,
And
sir.
then from $100, it's 100 times minus the 84, leave you with 16, right? Understand that? You see there? See there? She pays 70% times 120, which is 7 over 100 times 120. Listen to that goes that. No, not 7, 70. 70%. And then this is the, so you go 7 times 12 is 84, right? Here's the rate. In the exam, you can't calculate and say, do them kind of stuff here. Let's go again. 70 over 100 times $120. It's going to become 7 times 12 in the end. This 0 cancel this 0, this 0 cancel this 0. 7 times 12. 7 times 12 is 84. So she's paying $84 from it. So the change that she's getting from a $100 bill is 100 minus that 84, which is $16 change. And says A. But all right. Next one. This one for me. A store offer a discount of 15% on the total bill to a customer who spends at least $20. That looks like a $20. If a customer total bill is $80, how much must she pay? Let's look at it again. A store offer a discount of 15% on the total. Remember that this for you. This is 15. on the total bill a customer who spends more than, it's $20 this? So like $20.
Yes, sir. It's $20. $20.
It says if a customer's total bill is $80, how much will he pay? He's gonna pay 85%, notice. That's all, 80% of 80. I get in the discount, notice. You get the 15%, this 85%. He's gonna pay 85%. But that's how I'm gonna get 85%.
Yes, sir.
Times the $80.
68.
That's what they're working on. 85% times $80. So this into this goes that, and then this divided by the 10 give me 8.5. So it's 8.5 times $8. Music ready over here. Hold on. And then this divided by the 10 give me 8.5 times this 8. We can work out this quick in the exam. Is 8 times 8 first, and then 8 times 0.5, you know, that's what it is, you know. Because the 8.5 is same as 8 plus 0.5. So the 8 times 8, and then 0.5 times the 8. That's a quick way to do it. You understand? 8.5 times 8. You can't use a calculator.
Sir, 68, sir.
You cannot use a calculator. So you can say, okay, it's at 8 times 8 plus 0.5 times 8. Because 8.5 is same as 8 plus 0.5. 0.5 times 8. So this becomes 64 plus 4. See that? It's becomes 68. Because you cannot use a calculator in the exam. That is the answer. Okay, you can't use a calculator in the exam. So you have to do that. So if you want to set up like this and do 8.5 times 8, fine, you can do that as well. And work it out if you want to do that. You get me? So the 8 5 is 40. 8 64 and 4 68. You could do it that way as well. Multiply it all like that. Same thing. One did so. Next question. At a store, sales tax is charged at a rate of 2% of the cost of an item. The sales tax on a dress cost, which costs 180, this 180. It's cost 180. This is 180.
Sir, it was asking for the tax value itself.
No, it's asking you for the sales tax. The sales tax on this dress. Sales tax is 2%. So this girl's 2% of that.
Okay.
Yes, the answer must have 3069, don't it? Or 36, don't it?
Yes, sir.
2%. The number that they really multiply in this question is the 2 times the 80. Those are the substantive numbers they're multiplying.
Yes, sir.
It's 36. The only answer with that 36 in it is this. That has to be the answer. That has to be the answer. Right here. Now watch me now. Watch this, guys. Instead of calculating 2% of 1/8, look what you can do. You can say, okay, you want 2%, right? You can do this. Look, 10% is 80, don't it? And so, don't it? 1% is 1.8, don't it? See that? Therefore, 2% is 2 times this.
She's 3.6.
360. So this is the answer. So you can take them, break down the percentage and build it up back to where you want. Carry down to 1%. Instead of doing the calculation and all that. You can do that as well. So you want 2% of something, so okay, what is 1%? You get 1% divided by 100. You get 10% divided by 10. So if this is the whole thing, Then 10% is 18. So 1% is 1.8. So 2% is 2 times this. Simple as that. For example, put them on 2.5%. It will be 2%, which is this. And then the 0.5% would be half of that, which is 0.9. So it's a quick way you have to be able to do these things in an exam. You cannot use a calculator. Next one here. A man's taxable income is $20,000. Says he pays tax at a rate of 28%. Said the amount of income tax he pays is what? A man's taxable income is $20,000. He pays tax at a rate of 28%. So basically the substantive number you're multiplying, is 28.
See?
28 times the 2 are the substantive number you're multiplying in this question. Everything is other zeros depending on where the decimal place comes. So the answer must have 50, 69 somewhere, 5, 6. The only answer to 5, 6 are this. This have to be the answer. You don't have to worry about everything. The answer is on the paper. See that? To do the calculation, you have to multiply the 28, I taking 28% of 20,000. So in terms of the values that have substance that you have to multiply is 2 times the 28. The percentage and the zeros just a matter of where the decimal point is going to go. But the number of 56 in it. The only one with 56 is that one. So that has to be the answer. Must be the answer. You get me? But it's really 28% you're doing. 28 over 100 times 20,000. See? And all that happens that some zeros cancel. So them zero you cancel with them zero there. And they're doing 28 times 200. Right? So it must be 5,600. 28 times 200 is 5,600. That is it. Next one, right here. This one for me. A man's basic wage for a 40-hour week is $160. He is paid $5 per hour for overtime. This is 4. This is 4. This is week. For overtime. Week. All right, let's go again. A man's basic wage is 40 for a 40-hour week is $106. So you get the full $106 for 40 hours. He is paid $5 per hour for overtime. He's paid $5 per hour for overtime. If you work 6.5 hours overtime in a certain week, his wage for that week is what? So his wage is gonna be the basic plus the overtime.
Yes, sir.
Work on overtime by multiplying this overtime rate by 6.5 and add it to the basic regular week. What answer?
D, sir. 160 plus 32.5.
What again?
D, sir.
It's gonna be the regular pay, regular plus overtime is gonna be his pay, right? The regular is 160. They give us that already. 160 plus 5 hours times $5 times 6.5 hours. Because he gets 6.5. He works 6.5 hours at $5 per hour overtime. Right? So it's 6.5 times $5. Again, in the exam, you can use calculator to do the 6.5 times that. You can do the 6 times 5 first, and then do half times 5. 6 times 5 is 30. So this calculation becomes $30. And then half of 5 is $2.50. And then adding back this 160 over here. So. But understand that. Now this is what? This is 32.5. I added to 160. So it must be the last one here. So. See, that is a 32.5, you know. 32.5 plus 160 is that 192.5. Do this one for me now. Same question, you know. But see, in this question now, they tell you that the rate was 1.25. So over here, so they tell you what the rate was in terms of the dollar. Over here is the exact same question, but they gave you the rate as 1.25 times the hourly rate. And the hourly rate is going to be the 160 divided by 40. 160 divided by 40 is $4. That's a regular rate. And then the overtime rate is going to be 1.25 times that $4. That's where it becomes $5. Let's look at it.
Yes,
The
yes, sir.
regular rate. The regular rate. Becomes $160 divided by 40 hours. That becomes $4 per hour. $4 per hour is the regular rate. And so the overtime rate equals 1.25 times that $4. When you calculate 1.25, when you calculate the calculator, it's 1 plus a quarter. So the 1 times the $4 is $4 plus a quarter of $4 is $1. That's how you have to do it in the exam when you carry the calculator, guys. The 1.25 is same as 1 plus a quarter. So you do the 1 times $4 first, you get the $4 plus a quarter of $4 is $1. That becomes $5. And then when it's $5, it's the same as this $5 over here. So you do the same calculation over here afterwards. It becomes the same question. So you do the same calculation, same calculation after that. So that's the same 192. So it's the same question, they write a different way. That's what they do. On a different exam paper. All right, up here, sir. Talk to me, you do this now. Excluding sales tax, how much will be saved when a video which costs $12 is sold at a 20% discount? Your time. Give me half a minute. How much will be saved? Half a minute is 30%. Huh? If you get that discount of 20%, you're saving 20%. That's all. You save the discount. The discount is what you're saving. So basically, it's calculating 20% of that. No, sir.
2.4?
What's the answer?
2.4, sir.
Huh?
2.4.
2.4. You want 20% of 12. You can say, okay, 10% is 1.2. So 20% is twice that. 2.4. Right? If you want 20% of something, the 10% first. Is there 10% is $1.20. 10% of this is $1.20. Therefore, 20% is 2 times this. $2.40. That is what you want. The discount is the percentage. Next one. A store offer a discount of 10%. A customer will spend more than $20. If a customer, the same question we did earlier. If a customer total bill is $80, what is the actual amount paid? It's paying 90%. That's all. 90%. So the answer must have a 72 in it, don't it? 90% of this, 9 times 8 is 72. No, sir? Answer must have a 72 in it. This has to be the answer right here. Not complicated. That has to be the answer. You see it here, he pays 90% of $80, which works out to be $72. 9 times 8. Come, guys, we're not doing anything, you know. Your time, man. Come. Your time, do this one. A man pays 60 cents, and so give a question like this in cents, write it in dollar, write it in dollars, please. Write it in $0.60. You cannot be working cents and dollars at the same time. Convert the cents to dollars. So it's paid $0.60 for every 200 meter cube of gas, plus a fixed charge. If he pays this amount, when he consumes this amount of gas, how much is the fixed charge? So to know how much is the fixed charge, you're going to need to know how much of this money, the regular charge, he pays for this amount of gas and subtract it from that. Come, try that one for me.
So answer A.
Huh?
A.
A? Somebody say A. Come now, work it out. Work it out. Give me the 30 seconds. A?
Sir, A, sir.
All right, everybody said A. Let's see the working out. So I would say the fixed charge plus the variable charge is equal to this amount of money, right? What is that variable charge? We're trying to find this one. What is the variable charge? Remember, it's every 200, he pays 60 cents. So I don't know how many 200 is in this. So the variable charge becomes 55,000 divided by 200. That's the amount of 200 in this. For each of those 200 are paying 60 cents. 0.60. That's all equal to 178.75. And then we need to work this out. So again, there's some canceling down. Cancel this with 2 of this. That 0 here turn this into a 6. That 0 here turn this into a 6. And then 2 into this was 3 times. So it's really 3 times 55 we do it. 3 times 50 is 150. 3 times 5 is 15. So that's 150 plus 115. If you want to 3 times 55, you can quickly do 3 times 50, which is 150. 3 times 50 is 150. And then 3 times 5 is 15. You add them, get 165. So this works out to be 165. Can't use calculator, you have to do these things in exams. So the fixed charge plus 165 is equal to 178.75. So we have to subtract that. So when you subtract that, the only answer with a 0.75 must be the answer, don't it? See that? I'm subtracting a whole number from this. So the answer must have the 0.75 on it. So this has to be the answer right there.
Yes.
I have this number with this decimal on it. Subtracting 165, so the answer must have the 0.75 on it. Not everything has to be worked out. The answer is on the paper. You have to work out everything. The answer is on the paper. Get me? Next one. A plot of land presently valued $12,000 appreciates, increase in value, appreciates in value at a rate of 2.5% per annum, what would be the value of a plot of land after 1 year? New value is going to be 112%. So look at these answers now. You don't have to do no work at all on a question there. You must always look at the answers. If the land is appreciated, the new value must be more than 1,200, don't it?
It has to be more.
All of them answer are less. So it can't be none of them there. No calculation needed. The answer must be more than 1,200. I tell you guys, the answer is on the paper, not everything you have to work out. Right? The answer must be more than 1,200. So you can't use any of those. It has to be the one that is more. See? That is it. Must be greater than 1,200. So these are eliminated. I don't have to calculate nothing. This has to be the answer. The only one greater than 1,200 is that. I don't have to calculate nothing for this one. Be smart. The answers are on the paper. Not everything has to be worked out in a multiple choice paper exam. But the answers are there. See the answers. Be smart. You don't have to work out everything. If something appreciating value, it must get more. So all the ones that are less are eliminated. Share them less, that is it. The answer must be the one that is more. Not work on no. Get me? The answer,
Yes.
in a multiple choice exam, it cannot be working the questions and not looking at the answers. As you read the question, look at the answers. Because as soon as you see the answers, you can start eliminating stuff. And you can see what answer must be. Like I see that the answer for one of them must have a 6 in it. Can I say a 7 times 8? I will say at 9 times, you say a part of the question, you have to multiply 9 times 8 times 9, and I must have a 72 in it somewhere. So you're looking for the one with the 72. The one a while ago, you have something 0.75 minus a whole number. The answer must be the one with the 0.75. If you have something 0.75 minus a whole number, the answer must have the 0.75 on it still. You get me? So look for the one with the 0.7. Not everything has to be worked out, guys. You have to be smart. Most of someone are going to go work out everything, you know. I tried SWOT and member answers. Come out and cry in SWOT and realize the question change. This one, a loan of 8,000 was paid back in 2 years in monthly payments of $400. The interest on the loan as a percentage was, come do this one for me, write this one for me. $8,000 pay back 2 years monthly. Remember now, 2 years monthly, that's 24 payments, you know, guys. 24 payments, monthly they pay for 2 years. That's 24 payments. See that? 2 years monthly, 24. And each time they pay that amount, $400. They pay this amount 24 times. And I want the percentage interest. You have to know the interest divided by the original amount times 100. That's what you have to calculate. To know the interest, you have to know the total amount you pay, which is 24 times this. But understand that 2 years month is 24 months, that 24 payment. They're doing 24 times $400. That's the total we pay. And then you subtract the loan, that is the interest. Then the interest divided by the original amount borrowed is the percentage interest. So work it out for me, quick. One again. I'm gonna work the question. Work. Work the question. Come on. This 2 years is 24 months, guys. 20%. All right. All right, let's work it out. So you paid back $24 times $400, right? 4 times 24 is how much? 96. That's all. 4 times 20
It's 926.
times 4 is 16. That's
Buddy.
$9,600. Then pay back $9,600. And so the interest that he paid back is 1,600, don't it?
Yes.
No, sir? So the percentage interest
It's 20.
of 1,600 over the amount that he borrowed, which is 8,000, multiplied by 100. And yes, that's 20% because
20%.
is 2. 20%. Is the answer. Come, do this one for me now. Come on. Put pen to paper, man. Do this one right here, sir. This one. Let's do this one same time, too. The same question. The same question, just like that. You said that 125, 125. And another example, change this from 175 to 100. All right. This one is a loss. This one is a profit. So the same calculation, eh? 40%.
Say B.
And the one I don't know. I think about for 125, sold for 125. So you make a profit of $50, right? So it's 50 over 125 you have to do. You made a profit of 50%. And here you made a loss of 25%, $25. 25 over 125. All right. So for this one, the profit is 50, right?
Yes, sir.
So the percentage profit so it's 50 over the 125 times 100. That's what you're working out, right? You get 40 for that. That is it. I correct.
Yes.
About,
Yes, sir.
about this one. What is the loss?
You get 20.
The loss is $25, don't it?
Yeah, over the 125.
It's 25 over the 125 multiplied by 100. What do I get for that one then?
20.
20% loss. All right, over here now. The same question that you do all over, don't it? So you see they write it the other way around now. See it? Same question we do all over now. But they write it the other way around. It's a man pays 60 cents for every 200 meter cube of gas he uses, plus a fixed charge of 13.75. So this time they tell you the fixed charge. How much does he pay when he uses this amount of gas? So this is gonna be the answer, you know.
A, sir.
Put it out. So the same question and I kind of reverse it. This time I give you the fixed charge. So the answer is going to be the fixed charge plus the variable charge. And the variable charge is going to be the same 165 that we did before. Right? So he pays a fixed plus a variable. The fixed we know is 13.75 plus the variable is the 55,000 that he's using. By how many 200 is in it. And for each 200, he's paying 60 cents. Well, the 60 cents can't work in cents and dollars at the same time, work in dollars. So it's times 0.60. This becomes 165 again. The only one with 0.5 on it is the answer. It's the only one of the 0.75 I made on it. Down here. From this one for me. So refer to the table below, which shows the rates charged by insurance companies. So house insurance is 25 cents for every $100 and 50 cents for every $100 for content insurance. It says, how much will a person pay for insurance if his house is valued at 50,000 and content 10,000? Remember, try not to work in cents. So this is $0.25. This one. This one is $0.25. And this one is $0.50. So we have to do, you divide this by 100 and then multiply by that. And then divide this one by 100 and multiply by that. And add them up. What you got? We can't add no work, you know. You want to know how much 100 is in this? Multiply by 0.25. I want to know how much 100 is in this, multiply by 0.5. Want to get for the answer?
Look at this, sir.
A.
Yeah.
Want to get A? Want to finish it? Give you 20 more seconds. A again? All right, let's see. So for 50,000 is 50,000. Want to know how many 100 is in that? For each 100, you multiply by 25 cents. Plus 10,000. Want to know how many 100 in that? For each one, you're multiplying by 50 cents. Come on, Mr. Shaw. What is one work out to? The work out to 125, right? It's 5 times this 25, will give me 125, don't it? And over here, going to give me 50, don't it? Because this is 1 times this 5. We're going to get 50 over here, so. That's 175. Next one. Come do this one for me, quick and fast. This one you find in the principal now. Quick. Come on, youngster over there. So do this one on the screen. Come on. This one you transpose to find the principal. I equal PRT over 100. Try to find the P this time. Nobody? All right. So I equals PRT over 100. This question, this is the R. This is the I. This is the T. And trying to find the P. So the P becomes equal to 100I divided by the rate and the time. They're plugging in those values and put this up here. So. So 100 times $90 divided by the rate of 5% the time of 3 years. Want to get for that? 600? 600 again? Yeah, like 600 for true, for real. Because 3 into this goes 30, then into this goes 6, then 6 times 100 is 600. 600. All right, that is it. Next one, do this one now. Come on. Come on, come on. Come on, man. Work, work, work. Come on, man. Work. 7,000 borrowed at a rate of 5% per annum for 3 years. What's the simple interest? Quick and fast. Formula this one. I equal PRT over 100. Come on.
Sir, D, sir. D.
D as in dog.
Yes, sir.
D as in dog. All right. What's the options for the interest? I equals PRT over 100. Principal is $7,000 times the rate of 5 times a time of 3 over 100. That's it?
Yes, sir.
70 times 15. All right. Next one. Come do this one for me. Same question down here. So two of them are the same. The 2 questions are for me. Quick, 1 minute. A dress cost $180 is being sold at a discount of 10%. The amount of discount is easy. Huh? The discount is 10%, right? Good. 10%. Next one. A dress which costs $1,800 is being sold at a discount of 10%. See? The amount of discount is what answer? 180. But you see, somebody might see that question and think of the same person if they memorize it enough. I see the same answer 18 there, so. So if you try to memorize and realize that them change it from 180 to 1,800, you're just dead. That's why you have to make sure you're.
The answer C for another one.
Huh?
Sir, C for another one.
The answer is C, not really the letter. It's a valid answer. So what they do, they put answers in ascending order all the time. You get me? That's what they do. Right? So the answer is 180. You're just taking 10% of the value. That is the discount. Easy question D. Don't get these wrong. Too easy. Next one. The cost of a refrigerator is $1,850. A buyer who is given a discount of 5% will pay what? He's gonna pay 95%. Don't it? Talk to me what I work out to. Taking off 5%. What I want to work out to. Come, 20 seconds. 30 seconds. See it again? All right. Look how we do this question now. Oh, that's all right. 10% is 185. But it's 5% of one. So 5% is half of this. So 5% is, I can beat up to 95%, you know. Right? So 5%, this one like easy to subtract. 5% is half of this, right? Half of the 18 is 9. Half of the 5 is 2.5. No, half of the 180, sorry. This is really 180. Half of the 180 is 90. And half of this 5 is 2.5. 90 plus 2.5 is 92.5. So it's gonna pay the 1850 minus the 92.5. The answer is either this or that. Two answers ended at 0.5, don't it? Can't be this one because I want the more, don't it?
Your answer is C, sir.
Has to be C. So when I go up to the full work it out, you know, that's has to be this one. 0.5 answer that is less. That is the only 0.5 answer that is less. Answer with a 0.5 on it. Be smart. Next one. TT is $6 equivalent to $1 US. What is 15 TT dollars in US dollars? They want the 6 become 15. Come on. See the answer? Now memorize answers. I this guy 2.5 times is equal that, right? So that's a C for you, right? 2.5 times is equal that. That's what it is. Right? $6 is this. This amount is 2.5 times that, so it has to be 2.5 times the 1. You get me? Watch this now. You want 15, right? Watch this. Watch this. $6 is equivalent to $1, right? I mean TT to US. Watch this now. Here's a calculator. TT to US. 6 to 1, right? I try with 15. So 12 to 2, don't it? And then half of this now. 3 to 0.5. But understand that. That's what it breaks down to. If it's 6 to 1, then it's 12 to 2. So I have 12 out of the 15 already, you know, so I need 3 more. Half of the 6 is 3. Half of this one is 0.5. So this is 15. So this is the amount of US. 2 plus 0.5, $2.50. Okay, you cannot use a calculator. You have to kind of break it up, build it up. You cannot use a calculator. That's not the only way to do it. Good enough. Next one. EC 250 is equivalent to 1 is what is 20 EC? One is easy. Just multiply by 20, don't it? That's all. So it's 2.5 times this. That's 50, don't it? That's all. EC is that. Oh, you build it up to 20. Come. You build it up to 20. My bad. You build it up, you know, look. $2.50 to 1. That's EC to thing. They are get up to 50, 20. Okay, here's a calculator. EC to US. Do it like a ratio. $2.50 to 1. That's 5 to 2. I'm going to multiply this by 4 now. 20 to 8. That's the answer. $8. You want to see the calculation there? Look again, look again, look again. So I'm going to say it's $2.50 to 1, right? I want to know what 20 is. All I have to do is take this and build it up to 20 by multiplying by values. So multiply by 2 first. Get to a nice easy number, which is multiply by 2 first. Times 2 first. The times 2, this comes to 5 to 2. The more this reach 20 now, the times 4. Times 4. And the times 4, this reach 20. And this reach 8. So it's 20 to 8. So the answer is 20 to 8. What go to that? What go to that?
Yes, sir.
Next one. The same question in 2 different ways. At the end of a year, a car is worth 5% less than it was worth at the beginning. We did a question earlier. We did this question earlier and answer was 10,000, don't it? Remember?
Yes, sir.
Yeah.
Same question, them change it over here, so now. Look how them change it now. At the end of a year, a car was worth 5% less than it was worth at the beginning of the year, or them change the value, see? They change the value from this to this. So let's see, you know, double it.
And then change the year. One said December 2021, and one said December 2016.
Same question. All them do is double it. So the answer is gonna be double. See there? Hold on there. I want to work it out, don't it? Remember, the new value is 95% of what it was. So see there, 95 over 100 of the January value equals the December value of this. It was worth 1900 in December. 1900. That's what they're working out. All right? So the January figure is 19,000 times 100 divided by 95. All right? And this is just, see this? The 190 here is 295 in it. That's what happens. 95 that was one time, 95 into 190 was 2 times. So it's 2,000 times 100. That's 20,000 right here, so that's. But the same calculation with different values. Same calculation with different values. All right. Next one. So much page that is left. What time was we finished? 2 o'clock. All right. Let's 3 more pages of questions. Let's soon done. Let's finish them 3 pages of questions. Right? My God, we start past 9, about 9:30 we start. Nobody will tell you. Yeah, about 10:30 we start. All right, can't leave. Next one. A car presently valued 12,000. You know, so the one that come in or something for a while. That's serious. You don't do this to me, you know. I mean, I do it for you. Don't get it twisted. So, a car presently valued at $12,000 depreciate at a rate of 10% per annum. What will be the value at the end of 1 year? It's going to be 90%. Don't it? It's a appreciate, depreciate this time. Depreciate. So dropping in value. So it's one of these, you know. Can't be this one. So taking off 10%. So 90% to 1. 9 times 12 is 108, don't it? Half to be the answer we 189. Bang. Has to be the answer. 108. Okay, I'm doing 90%. New value is 90% of the 12,000. They're taking off 10%. Substantially, you're multiplying 9 times 12. 108. All answer 108 is the first one. This has to be the answer. I don't have to work it all out. Be smart. You don't have to work it out down to the wire. The answer is on the paper. Remember, the answer is on the paper, guys. Next one. Annual interest rate of a mortgage on a house assessed at a value of 450,000 is 5% for every $1. 5 cents, sorry, for every $1. What is the interest paid on a mortgage for the first year? 5 cents for every $1. Come on, do it. 5 cents in every $1. Change this to change that to dollar. You basically got to change this to money and multiply by that. That's what you're gonna have to do. Every $1. And this is 450,000 $1 in it. That's what it has. 450,000 $1 in it. Substantially, the answer is 5 times 45. Substantially, that's the answer. 5 times 45. That's what we realize with these questions. Not everything else will be real though. Whichever of these answers result in 5 times 45, those substantial values, That is where your answer is. But everything else is just a matter of ending with zeros or with decimal points, or where decimal point is. So the answer is 5 times 45. What is 5 times 45? Huh? 225. So this has to be the answer. Must be the answer. There's 450,000 times 0.05. We multiply these values. So this is the answer right here. All right. A dinner at a restaurant would advertise at $60 plus 18% tax. What is the total bill? Can this one, we can do the 18% and add it to the 60. Or the 18% pass. The 10% plus 8%. 10% plus 8%. 10% of 60 plus 8% of 60. And they add that to the 60. That's where it add. That's where you add it. That's where you get it. So $60. $60 plus 18 over 100 times $60. Take a look at it that way. The amount of it plus the tax. Right? So $60. So 18% of 60 is 10% first, which is $6. So 10% plus 8%. Plus 8%, which is 6,840, right? $4.80. That is the answer. This is the answer. This figure is your 10%. This figure is your 8%. 10% of 60 is $6. So 8% is 4.8. Because 68 is 48. 4.8. That is it. And they add up everything. As I said, each book was marked at $3 off the original price. Do this one for me. Do this one for me, please. At a sale, each book was marked $3 off the original price. Daniel paid $46 for 2 books that he had at the same price. What was the original cost of one of the books? A. But I agree that. Nice. You divide by 2, so you pay $23 for each, right? And the $23 included a $3 Hold on. Nope, I'm not hear the answer. Let's go again.
The answer.
Huh?
B is the answer.
The discount in there, they have add it on back. Right? So at a sale, each book was marked $3 off the original price. Right? $3 off the original price. So if you pay $46 for 2 books, it means they get $6 off the original price. That's all. Don't it? So you would have originally paid $52. Don't it? If you never get the discount, right? That's all. That's just 2 books, you know. So you got a total discount.
Say that again, sir.
I said if he bought 2 books and paid $46, it means that he would have originally paid $52 because he got a total discount of $6. So if I add another $6 here to the 52 to see what the original total he would have paid, he would
Yeah.
have originally paid $52 for the 2 books. And then divide that by 2 to see how much he's paying for one, which is 26. Another way you can work the halfway route. So if he paid $46 for 2 books, then he paid $23 for one. He paid 23 for one. Paid 23 for one. This is after I got a $3 discount. Therefore, the original price is the $23 plus by the $3 discount, which is $26. So there's multiple ways you can do it. But that's not that. If it's 2 books in buying with a total discount of $6, and he paid 46. So the original amount he would have been $52. Add 6 to this, you get 52. That would be for 2 books originally. Divide that by 2, you get 26. 26 is the original price for one of those books. That is it. All right. Next one. Up here. At a store, 3 cents in every dollar spent is charged as sales tax. 3 cents in every dollar is charged as sales tax. How much is paid for sales tax on a costume which costs $196? Write that one out. 3 cents. And that's 3 cents in every dollar is spent. 3 cents to $1. And this is the amount of dollars spent. So it's 3 cents times this amount of dollars, 196. So you will multiply 3 cents times this to get the answer. So the substantially I'm multiplying 3 times 196. What? Because all these digits different, it is to work out. Huh? A. Because 3 times 196 is 588. That's it. All right. I see this 3 cents. This 3 cents, remember, you work as dollars, guys, is 0.03. So $0.3 for every dollar. And this is the amount of $1 that he spent. 196 $1. So 196 times this is the answer. 196 times 0.03. That's what you're multiplying to get the answer. So substantially, you're multiplying 3 times 196. What are those digits? This one. Yeah, this is the answer for you. It's almost 200. 3 times 200 is 600. It has to be a value less than 6. That's it. But go to that. Next one. The value of a plot of land is 80,000. Land tax is charged at 77. We do this one already? This very one, you sure? You multiply 7 times 18, right? That's 126, that's all. Same question, 126. We have to multiply the 7 times the 18 at some stage. All right, we did this one already. Mrs. Jones, Mr. Jones bought a car for 64,000. Car depreciated at 20% for the first year and 10% each of the following years. The value of the car at the end of the second year was what? What is the value of the car at the end of the second year? Come on, read this one out for me. So at the end of the first year, it is 80%. And then at the end of the second year, it is 90% of that. First year depreciated by 20%. So the value of the car at the end of the first year is 80% of the 64,000. And then now, it's going to depreciate by another 10%. So the new value after the second is going to now be 90% of that first year ending value. Then work it out and work it out. So it's 90% of 80% of 64,000. That's what you're working on. Everybody get it? First year ending value is 80% of this. Then you're doing 90% of that value. Huh? See? CSEC. I don't know the answer. See again? Nobody else? But online finish it? Girl, you can't calculate an exam. Can't calculate an exam. You practice without the calculator. You can't use calculator in an exam. You practice without the calculator. Look, the first year value is 80%. That's 80 over 100 times the 64,000. That is the first year value. And then on this value, you're taking 90% on that value next. They can now multiply this now by 90%. That is the calculation that you do. That is what you calculate. This is the first year ending value. 80% of 64,000. And you're taking 90% of that. Okay? Depreciate it by another 10%. That's what you have to work out in the exam. So to get a final answer, you really need to be multiplying 9 times 8 times 64. Those are the three substantive values that you multiply to get the answer. 9 times 8 times 64. 9 times 8 is 72. 72 times 64 is what you really multiply. Whichever digits match up to that, you go, that is the answer. Whichever digit, all these have different digits. Whichever digit match up to 9 times 8 times 64. Gonna be your answer. So the 9 times 8 is 72. 72 times 64. 72 times 64 is what you're working out. 72 times 64. So 2 times 4 is 8. 2 times 6 is 12. 7 4 is 28. 7 4 is 28. And then 7 6 42 and 2 44. 7 6 42 and 2 44. That's what they're adding up. So 8 0 6 4. So this is that 4 6 0 8. This. That's it. But that's on the calculation. But that's on the calculation. So guys, you understand why I multiply the 9 times the 8 times the 64? Because all these have different digits. So those are the substantive values in terms of the digits that you need to get in the answer. Because the zero is gonna just basically place the decimal point, tell you the number is in thousands or whatever. In terms of the values that they're getting that are substantial, it is 9 times 8 times 64. The 9 times 8 is 72. So I'm multiplying 72 times 64 right here. Comes down to this. The only answer of those digits is this one. That's why I know that is the answer. All right. That must be the answer. All right. Next question. See the same question. I reverse the thing now. So the plot of land is valued 18,000. Land tax is 126. Is charged annually. What is the per annum amount? So basically 126 over this times 100, you know. The land tax is 126. This is the amount of the land. I want to know the percentage. So it's 126 over this times 100. At what rate percent is land tax? 126 over this times 100. 126. Oh, you know, do it for me. Come on. 10, 20 seconds. Do it. Check the time. Huh? Oh, 1 minute. 1 minute. You want to spend more one and a half minutes per question. How about 1.5 minutes per question? This one you have to be careful because all the values are sevens, right? So basically careful the size of the number now. So it's 126 over 1800 times 100. Right, so basically you're gonna get, cancel it down. Bang, bang. That's gonna be 0.7. See that? 126 over 180 is 0.7. That's the answer. Next one. Exchange rate of $1 to $2.70 EC. What is the value of 450 US? That one easy. Come on. It's 1 to 270, and I want to know how much is 450. Just multiply. Multiply this times this. That becomes 450 times 270. Become fast. What again? Look on this one. This one not for work out, you know. Because 270 times this has to be more than this. That's all. 2 times 4 already are 8. Has to be more than them first three. Don't it? See? So I'm telling you, I always check the answers and look what makes sense. All right, so you're doing 2.75 times 450. Has to be more than this. Has to be. Because 2 times 4.8 already at 9. So this has to be the answer. Next one. A man's annual salary is 45,000. His tax-free allowance is 13,000. He has to pay a tax of 20% on it. What is the tax? Come on, do this one for me. 1 minute. Come here, ready, we'll do this number and stop, look for whatever. So the salary is 45,000. Tax-free allowance is what you subtract from the total to see what is the tax. You get me? That's what the tax-free allowance is. You subtract the tax-free allowance from the total pay to get the amount that you tax. Right? Hello, mom, on there, sir. Hello. Mom. Is there not discipline now? Totally out of it. I don't want to get good result in the exam. Do the question, man. I don't want to get mad inside here. So subtract the tax free to see how much is the taxable. And calculate 20% on the taxable. Ready? So the taxable. The taxable becomes 45,000 minus 13,000. 45 minus 13 is what? 32. And therefore the tax equals 20% of that taxable amount. And the substantive number I multiply is 2 times the 32, which is 64. The only answer with 64 in it is this one. So that must be the answer. You have to work out everything, guys. All right, next one. Do this one for me. Come on, 1 minute. A television set costs $350 cash. When bought an higher purchase, a deposit of $35 is required, plus 12 monthly payments of $30 each. How much is saved paying cash? The work out how much you pay under this system, 35 deposit plus 12 times 30, and then subtract 350 to know how much is paid. And then buy cash.
D.
Huh?
45.
45. I worked out for me now. See, somebody worked out and see. Do you get to? So for the total amount that you would pay, 35 deposit plus 12 times 30. 12 times 30 is 360. 360 plus 35 is 395. 395 minus 350 is a 45. So that is correct. All right. So he pays $35 plus 12 times $30. He pays 35 plus this is 360. He pays 395. And therefore he saves 395 minus the amount that you would have used if he paid cash, is 350. Which is $45 right here. That is it. So 1 page left after this. Finishing strong. Let's go. The annual interest rate on a 15-year mortgage on a house assessed at $450,005 every dollar. What is the interest paid on a mortgage for the first year? The same question we did earlier, don't it? Same question we did, don't it? We multiply this 5 times this 450, don't it? So that's substantive value that we have to multiply. Because 5 cents just means 0.05, you know. So 0.05 times this 450,000. So you multiply because for every $1, and there are 450,000 $1 in this. So it becomes 450,000 times 5 cents. 5 cents is $0.05. That's what they multiply. So substantially, you're multiplying this 5 by this 45. And 5 times 45 is 225. That's all. Yes. 5 times 40 is 200. And 5 times 5 is 25. 225. So the only answer with 225 in it is this one. But those are the substantial numbers that you multiply. This times this. All right. So I tell you, do have to work out everything, guys. This times that are the substantial number they multiply. And so get it 2 times. See? 5 times 45 is 225. It's the only value that 225 in it. That must be the answer. Next one. Next one says, Mary invested $200 for 5 years at 5% per annum. John invested $500 at the same rate. If they both receive the same amount of money in simple interest, how many years did John invest his money? Interest is the same. Come now, work it out from one again. $200 for 5 years. So it's gonna be $500 for 2 years. Makes sense. It must be 2 years.
Yes, sir.
And
Two.
yeah, if it's $200 for 5 years, it has to be $500 for 2 years. If the interest rate is the same. You get me? So let's look at it. So the interest by Mary is equal to the interest by John. Interest is PRT over 100 for Mary equal PRT over 100 for John. All right, this is for Mary on this side. And over here says for John. What are the values? Remember the rate is the same for both of them, you know. Since the rate is the same, look, let's mark what is different. The principal for Mary is different from the principal for John. And the time for Mary, I mean to put G. And the time for Mary is different from the time for John. But the rate is the same, so the rate them go and cancel each other. The 100 and the 80 and cancel 100 and 80. So it becomes that the principal for Mary times the time for Mary equal the principal for John times the time for John. Right? Now the principal for Mary was 200, and that was for 5 years. Principal for John was 500 times the time. So this side is 1,000, but this side has to be 1,000, this has to be 2. So T has to be 2. T equals 2. So that's the answer, T equals 2. Some question I really work out almost that common sense. Next one. A salesman sells a car for $11,000. If he is paid a commission of 4.5% for the first $10,000 and 7.5% for the remainder, then his commission is what? So you get 4.5% for the first 10,000 that, and then 7.5% for the 1,000. So it's 4.5 over 100 times the 10,000. And then for the additional 1,000 that he sold for, he gets 7.5% for that. That's what they calculated. That's what they calculated. So simplify them down quick. 100 into that goes 100 into that. Then 100 times this give you 450. So this is just $450 plus over here now, same kind of thing. 100 into this, 100 into that, then it becomes 10 times 7.5, give you 75. $75. And these two add up to 525 right here. This is it. All right, last page. Last page today. 1, 2, 3, 4 questions. Not only 4 questions I'm coming today. Now, who? Let's go. Same kind of question. A salesman sells a car for 10,500. If he's paid a commission of 5% for the first 10,000 and 8% for the remainder, then the total commission is same question, different values. Come on, do this for me, man. Serious. Seriously, man. Seriously, man. Put up the clock now. Seriously. 1 minute. Put up the clock. You get your whole day, you want about this somebody look on phone. Do this question. Come on. I'm not joking. 1.5 minutes. Come on. That's the time you have for a question in the exam. 1.5 minutes. This one on the screen right here. This one, you do it. Work it out. Come on, let me see. Little girl, work out the question down. Just the one, just like it a while ago. Come on, easy stuff. 5% of 10,000 and 8% of $500. Easy. Huh?
Let me get A.
You get A?
Yeah. Hold on.
Check it again. Check it.
Oh wait, no, not A, not A, not A, not A. Mistake. C.
All right.
E.
5% of 10,000 and 8% of 500. That's what it's gonna be. $25 seconds to go. Come on. Want to have another class tomorrow? We do 2 more topics in 4 hours tomorrow. Let's just run online not need. I'm gonna come class and not pay attention. Online I'm gonna pay attention. Huh? Not joker, jokers. Come on, the exam a ball. Sir, what's the question there? Come, 5%. 5 over 100. And the first $10,000 plus 8% of the remaining $500 here. 8%. So this one is just $500, right? Plus this one is just 8 times 5 is $40, right? That's $540 again. 500 plus $40. Come, 1.5 minutes. Do this one for me. Come on. Start the clock again. 1.5 minutes. Do this one. Come on. A company employs 20 persons as gardeners and clerks. The mean daily average of all employees is $22.40. If each of the gardeners paid $26 per day, then the daily amount paid to each of the 8 clerks is 20 some more time for now. 3 minutes. Start. Come on, do that one. Max it out. I give you the average, the weighted average. So 20%, they give you the salary for 12 of them. So remember, I know the total salary divided by the 20 is in mean. That's where you're gonna start. Total salary, which is the 12 gardeners times $26 plus 8 gardeners times the salary for the 8 gardeners that they don't know. By 20 equal the mean of $22.40. And we work out what the class salary is. The mean is the total salary of all employees divided by 20 of them. That's what the mean is. They tell you what the mean is. They're setting up an equation. It's what they don't know. It's the clerk's salary. This gardener is $26. The total salary for the gardener is 26 times 12. Then the clerks, 8 of them. So 8 times the salary. That's the salary for X.
Oh, I think that's me.
That equals the mean of $22.40. Transpose to find the X. And that set it up like an equation. The unknown salary is the salary of the clerk. It's 8 of them. Come on. 1.5 minutes left.
Sir, Andros, you.
Huh?
C. Yes, sir. May start a little late.
Everybody get it? Get see it up? All right, look. To tell you the mean, right? You have set up an equation and put in like an X or something what they don't know, the salary of a third, right? So the total salary will be 12 times this. 12 times $26 for the gardeners. Plus the 8 times the salary of the clerk, call the salary of the clerk extra, I don't know it. It's a total salary of the 20 staff. Divide the total salary of 20 staff by 20, because 20 staff, that equal the mean salary of $22.40. And then this way you're solving trying to find X. Solving that for X by whatever means necessary. Transpose and solve for the X. Then you multiply, every now and then they give a question and a multiply table. You really have to do some work. You get it? You get me? So you want to simplify this down the easiest way possible. I can take this and multiply it across here. But I prefer to multiply by 10. So what I'm going to do is divide out 2 out of this first and make it 10. 2 out of this make it 4x. 2 out of this make it 6. Then the 10 I multiply it over here, so no. So when I multiply the 10 over there, this side going to become 6 times 26. So 6 times 26 is what? 6 times 20 is 120. That's 6 times the 20 is 120. And then 6 times the 6 is 36. 36. So you add them here, 156. 120 and 30 is 156. So this becomes 156 right here. So I get 156 plus 4x equal multiply the 10 times this, so I don't have a decimal I work with anymore. I get 224. Solving this for x. Multiple it. I can divide 2 by 4. Can 4 go into this? 4 can go into this. Can 4 go into this? 4 into, yes, 4 can go into this because 4 into the 15 is 3. Remain at 3. Then this into this give me 39. That's right? 39. That looks like 39. 39 over here, so. And then 4 into this is 4 into the 20. 4 into the 20 give me 5. Let me do 24. 24. 6 4 is 54, right? So this becomes x equal this plus this how much now? 36, right? 36. And we subtract the 36. X equals 54 minus 36. 36 that? Oh, 56, yes, 50, not 54, 56 times. 56, yeah. 56. That's 56. What is that 36? That's a 56? It's not a 36 then. That answer not there. Something is wrong. $39. Oh, 36 divided by 4 is 9. 39. Beautiful. Thank you very much. That's 39 right here, all right? Plus x equals, it's a 56. So x equals 56 minus 39 is 70. Yeah. So we know when I get that question, you have to actually work it down, right? Come on, maintenance for this one. The learner invests $5,000 for 2 years in an investment scheme. The investment earns compound interest of 8% per annum. What will the amount of the learner's investment at the end of 2 years? So for this question, what's the amount of his investment of a 2? So you know, so them 2 years out of it, right? Them 2 years out of it altogether, right? Don't it? Because I'm less than the thing. The one the amount of his investment, that is the total amount. So what you have to do, you can work out you can work out 8% of this and add it to it in the first year. Good. And then now you're gonna add 8% of back value again for the second year. Or you can set up like this. It's actually 108% I'm doing, you know. New value is 108%. This is mad. Give you 3 minutes to do it. Start. Basically, you're gonna have to add 8% for the first year, and then the new value, and then add 8% again of that new value. They can work out 108% of this first, that's the new value. If we get the new value, you work out 108% of that new value again to get the value for the second year. Right? It's compounding the interest, compounding interest. So the money is growing by 8% each year. Compound. So after the first year, the new value is 108% of 5,000. In the second year, it's going to be 105% of that first year value. But it's compound interest. Is 540. 8% of 500 in the first year. Just 400. You know, so the answer has to be the last one. Let me tell you what your result what the answer has to be the last one. We're not working on everything. The last answer must be the correct answer. All right? Look why the answer has to be the last one. We don't working on everything. That is compound interest, right? What is now? The first year interest, what is? Sorry. What is? Year one. Year one interest. What is now? Year one interest is 8% times 5,000. So 8% of 5,000 is 400, you know. What can I say that? Sorry. Right? 400, don't it? $400. So it's adding $400 in the first year. So the interest is compounded. You have to add more than $400 in the second year. But that's not. See that? So if you was only adding an additional 400 in the second year, the answer would have been this. 5,800, don't it? But I agree with that. But because he's adding more than 400 in the second year, that can't be the answer. The answer has to be this one down here. Because the second year interest must be more than 400. Because he's now doing 8% of $5,400. See there? So you see, when you add 4% in the first year, the value becomes 5,400 enough. Then it's adding 8% of this now. 8% of that cannot be 4,400 more. So if the first year amount they add was 400, second year you have to add more than 400. So it can't be that the second year total is 5,800. Because you have to add more than 400 in the second year. But that's what I'm saying. Without working out the full thing. Second year interest has to be more than 400. So the total value after the second year must be more than 5,800. Can't be 5,800. Has to be more. What is it? So you're working it all out though. The year two interest would be 8% of the 5,400 now. Which becomes 400 and then 8% of this. 8% of the 5,000 is 400 again. But then 8% of this 400 is 32. 8 4 is 32. So it's a 500 and 432. 432. This amount is adding in the second year. So the new value, the value becomes 54 plus 432. That's why the answer is this. But I didn't have to work it out. Once we do the first year and get 400 of the interest, because the second year interest has to be more than 400. You're charging 8% now on a larger amount. You can't be 400 again. So the final value has to be more than 5,800. So you're adding more than 400 in the second year to the 5,400 that you already have. So the answer has to be the last one without working it out. But that is it if you were to calculate. One question left. Megan normally saves X dollars each month, but in August, she saved $4 less than twice her annual amount. In August, she saved what? This one kind of straightforward. She normally saves X, but in August, she saved $4 less than twice the usual amount. How much she saved? What the answer? Huh? Say $4 less than twice the usual amount. So what she say? Huh? Which one is the answer? She normally saves X. In August, she saves $4 less than twice the usual amount. So much she save in August? Huh? D, C, $4 less. You say subtract 4 from twice the usual amount. The answer then on your calculation. That is just. All right, guys. What is that? 10 o'clock tomorrow again?
No, sir, that's too early. Me I go church. Can do it in the afternoon, like 2:30 or 2 o'clock or so.
Can't do it at that time. Can't do it at that time. That's because the 4 session. I finish it by 2 o'clock. I'll do the session and finish it around 2 o'clock. That's what it is.
Okay.
Tomorrow, same thing again. All right. So it's gonna be 10 to 2 again tomorrow, guys.
So, sir, you can record it and then watch it afterwards then?
Yeah, it's gonna be recorded. It's gonna be recorded. Gonna be recorded. All right, everybody. You, mom, you need to go and do what question. Now, pinch, you know. You see, I joke on this thing.
Okay, sir, thanks.
Bye. I'm gonna end it now, everybody. Bye. I'll share the video in the group.
Okay, thanks.